Hi guys, welcome to today's lecture. So what are we focusing on today? I wanted to discuss or revise actually some basic maths with you guys, keeping in mind the entrances for masters like IGIDR, Madras School of Economics, Gokhale Institute, and so on and so forth. There's generally a basic maths part which is asked out of you guys, is expected out of you guys, which is compulsory in nature. So you have to attempt that part. So let's start with this revision. I'm starting off simply with the real number system, and we will keep on increasing the intensity of this revision. This is the part of one of the revision. Let's start. So real number system, you need to understand what kind of numbers we have. In general, at your level, we are working with the real numbers. Now, real numbers could be divided into integers, whole numbers, and your natural numbers, rationals. How does it go? So you have your natural numbers, that is, these are just the integers, positive, strictly positive integers starting from 1. These are your natural numbers. So this is the smallest set here. And then a superset to it is the set of whole numbers, which just consist of an additional number 0. Now, with that, you can talk about the next set, superset, which is the set of integers. It contains the negative integers. So minus, 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 minus 1, minus 2, so on and so forth. All the integers that you have. So that is your set of integers. And bigger than the set of integers would be the set of rationals. Now, rationals are fractions in between. So all the numbers that are, you can represent in terms of P by Q, they are rationals. On the real line, you also find some kind of numbers which are called irrationals. Now, irrationals are also a part of the real number system. On the line, you can have rationals as well as irrationals. In fact, since rationals consist of all the other categories, so hence your set of real numbers could also be represented as the union of rationals and irrationals. Now, you can broadly divide your numbers, your natural numbers, your integers in terms of even numbers and odd numbers. What are even numbers? Even numbers are basically the numbers which are divisible by 2. And the numbers which are not divisible by 2 are called odd numbers. Now, the rules of multiplication when it comes to even and odd should be very clear to you. Odd multiplied by an odd number will give you odd. Even multiplied by even number will give you even. Even multiplied by any odd number. Suppose you're multiplying 2 and 3. 2 is an even number. It's divisible by 2. 3 is an odd number. When you will multiply, you will get an even number always. So whenever you multiply any number by an even number, you will get an even number. The set representations for odd and even. Even number, as we said, they are divisible by 2. So we can say that if k is an integer, then twice of k will be an even number always. If k is an integer and you are talking about an odd number, that would not be divisible by 2 and would be represented as 2k plus 1. In cases, this index could also be 2k minus 1. But you need to have this clarity, what is odd, what is even representations. Then comes a very important kind of a number or a function or an operator. What is this operator I'm talking about? Modulus or the absolute value. In the previous videos, I was talking about the absolute value, in fact. So modulus of x is x when x is a positive number. It is minus x when x is less than 0. Now, by doing minus x, what essentially happens? Suppose I take a number which is less than 0, say minus 2. So we will say that modulus of minus 2 is actually 2. And how are we getting that? Minus of minus 2. So therefore, I will get that just the absolute value. This is what is an absolute value. Now, what I want to focus here on are the 4 rules for modulus. So absolute value of x into y is same as absolute value of x multiplied by absolute value of y. Absolute value of x upon y is same as absolute value of x upon absolute value of y. Absolute value of x plus y is always less than or equal to absolute value of x plus absolute value of y, and that's called the triangular inequality. And another important inequality is that the absolute value of x minus absolute value of y, that's always less than or equal to modulus of x plus y. So what do you get from here? So you can say that this mod x plus y is always less than or equal to mod x plus mod y, but it's always more than or equal to modulus of mod x minus mod y. So please keep these inequalities in mind. Now let's work on a modulus question. So the question I'm asking you is, modulus of x plus 1 is equal to modulus of x minus 1. For what x can this happen? Well, can you think logically here? As a layman, if you have to work on this question, just think of some numbers here, which can give you the same value. Well, I have x plus 1, x minus 1. I know that in case it would have been just plus 1, the absolute value would be just 1. In case it would have been minus 1, the absolute value of minus 1 will also be just 1. If I will put x equals to 0, modulus of 1 will be equal to modulus of minus 1 because both will give you the same value 1, right? So yes, this is happening for x equal to 0. Now, food for thought. Will this happen for some other x? Can this happen for some other x? There couldn't be any other number which will give you this equality, because for any other x, this expression will keep on changing. If the expression will keep on changing, you will not get the same thing outside, right? Next brush up point is binomial theorem. So at times, binomial theorem questions could be directly asked. Otherwise, you should know the binomial theorem for few things. For certain formulas, you can create the formulas for yourself. For the knowledge of combinations, counting, you should know the binomial theorem. Now, the binomial theorem says that in case you look at a plus b to the power n, that would be equal to NC0, a to the power n, b to the power 0. NC1, a to the power n minus 1, b to the power 1. The total you will always see in the power is n, okay? NC2, a to the power n minus 2, b to the power 2. Again, the total is n. Till the point you are taking NCN. Combination NCN means you're selecting all n out of n. NC1 means you're selecting 1 out of n. NCN, a to the power 0, b to the power n. Again, the total is 1. Some basic formula that you can construct out of it is, say, a plus b square. A plus b square is clearly a square plus 2ab plus b square. All you have to do is give n the value 2 and create this. So, of course, you can just go up till here, NC2, because that's your n, right? N is 2. Now, in the case of a plus b cube, your n is 3. So this will turn out to be a cube plus 3 times a square b plus 3 times b square a plus b cube. And that's how you can generate all the formulas for that matter, okay? If a is equal to b and is equal to 1, this is a special case. When that happens, that means putting in the binomial theorem, I would realize that I have 1 plus 1 to the power n. That will give you 2 to the power n. This is nothing but 2 to the power n. Now, what is 2 to the power n equal to? A and b both are equal to 1. Because both are equal to 1, that means what is happening here is that every time NC something, NCK is getting multiplied just by 1. So on the right hand side of the binomial theorem, you will just have NC0 plus NC1 plus NC2, so on and so forth till NCN. Now, what is this expression all about? As I said, NCK is nothing but selecting K out of N. So NC0 means I selected nothing. NC1 means I'm selecting just one. NC2 means I'm selecting two, and so on and so forth. NCN means I'm selecting all. So this is the total number of selections possible from given n elements, and that's equal to 2 to the power n. This is a very powerful formula actually, okay? And from here, you also gain another knowledge that the number of elements in a power set is 2 to the power n. What is a power set? I'm going to talk about this. Let's understand what sets are. So, quick recap for sets. Sets is basically collection of elements. It could be any kind of collection of any kind of elements, okay? So there are certain things around sets, certain operations and all that you must know. You should know working with the sets. So this operator that you see here, the symbol that you see here, this is for subset. Now, what do you mean by subset? M is a subset of n. M is a subset of n. Suppose this is the set n, and M will be a subset of n if everything inside M is also inside n. So in some sense, M is smaller than n and it's contained. This symbol is for containment. So we will say that every x belonging to M logically will be in n as well. Then only I will be able to say that M is a subset of n. When I have this symbol here, this dash here, if I have this symbol here, this means that it can also be equal. These two sets can also be equal. That means they have exactly the same elements, okay? If this thing is not here, that would mean that it's a proper subset. Now, proper subset would mean that M is properly smaller than n. You know, there would be some extra element in n. They are not equal. Okay, so this is called proper subset. Now, a power set which contains 2 to the power n elements. A power set is basically the set of all sets or all sets that are actually subset of M. If I'm talking about power set of M. Then if you have a set, say 1, 2, 3, suppose M is 1, 2, 3. So it consists of 1, 2, and 3. What is the power set of M? Power set would mean that I am selecting nothing out of this set. Nothing selected means a new set, which is phi. Phi is a set of nothing. Phi is a set which contains no elements. So phi is in this. This is your NC0. With NC0 selection, zero selection, you get phi. You're selecting just one element now. In how many ways can you do that? Maybe you just select 1. Maybe you just select 2. Maybe you just select 3. Mind you, all these are turning out to be, these are subsets of M, right? You can see that for yourself. Now you will select 2 elements. You have 3 elements in total. When you select 2 elements, there could be combinations 1, 2, 1, 3, 2, 3. These are the combinations that I can have. These are the subsets which contain 2 elements. And then there is NC3. That is, you're selecting all 3. So how many total elements you have in your power set? Power set contains sets. Those sets are elements of the power set. So you have 8. Your n was 3. 2 to the power 3 is 8. So you have 8 because you've taken care of all the selections, and power set is nothing but all the selections that are happening. Okay, so that's what is a power set. Okay. Equality in sets. So as I told you, M could be equal to N. The two sets could be equal as well. Now, when will they be equal? They will be equal if and only if M is contained in N and N is contained in M. Both the things should happen, okay? Then only they will be equal, because think about it as a Venn diagram, if you would like to think in terms of a Venn diagram. So suppose this is one set, M, and this is another set. So I wanted to, every element in M is in N, and every element in N is in M. When is that possible, boss? That's only possible when both of them are equal. They have same elements. So actually the crux of the story here will be that they have same elements. Okay. Now, some more things about sets, which I'm sure you should know at this junction when you're sitting for all the entrances and all. What is union? What is intersection? Union of two set means the elements which are either in M or in N. When we say either in M or in N, it includes or in both, okay? That is a part of it. So it's a set of all x's such that x belongs to M or x belongs to N in maths, or both is included in, okay? It's an inclusive statement. Intersection is a set of all x's such that x belongs to M also and x belongs to N also. So it is a scenario like you have one set, you have another set. The intersection clearly here is this portion. And the union, if you are interested to know, the union is the entire thing, including the intersection. So union includes intersection, and all these visualizations should be very clear to you so that if a question is thrown to you, you're able to set theoretically visualize it. Not just Venn diagram, but also in terms of set theory, you're able to solve, okay? And this is a basic thing expected out of you. Venn diagram questions where they can give you a numerical, they can ask you that kind of question in any basic maths exam. Also something in set theory you should be very careful with is the De Morgan's law. There are many times where you're able to use De Morgan's law. So the moment in a question you have complements and unions and intersections somewhere, please be careful, and maybe you're able to use De Morgan's law. Now, De Morgan's law says that A complement and B complement, if you take the union of the two, what it is equal to? It's actually equal to the complement of the intersection. So let's create a Venn diagram here. Let's say you have A and B. Suppose this is A and B. Now, whatever is not in A is its complement. Okay. So everything that's not in A is its complement. Now, everything that's not in B is its complement. Everything that's not in B is its complement. Okay. All this is its complement. Okay. Now the union of these two. The union of these two is where you can see green as well as you can see red. Because we're talking about union. So either or. So everything that you see beyond this intersection, everything that you see beyond this intersection actually is a part of this red and green that I've marked, right? So, which essentially means this intersection is A intersection B is here, and the complement of it is everything that you have outside. That's the complement. So hence, this is what the De Morgan's law says. Because this happens every time, no matter what kind of Venn diagram you create, this will happen actually. So the second part is for the intersection. So De Morgan's law says that A complement, intersection B complement is A union B complement. So complement of the union. So union of complement is complement of intersection, and Intersection of complements is complement of the union. So this is very important for you to note down. And this is the homework for you. You must try out the second one. Next comes very, very important portion for any entrance, be it basic, be it advanced. But yes, even in basic exams, of course, they will ask you domain range for any given function. By now, if you have been following my videos, you would know clearly what functions are. So a function is a relation where for each input, you have a unique output available, okay? So for every x, say belonging to, if I am taking a function from A to B, belonging to A, there exists a unique y belonging to B such that f of x is equal to y. Unique is important, okay? So what is domain? That means domain is the word given to the set of all pre-images, all x's or the pre-images. Every input which has an image. That's called the set. That set is called domain. Range is the set of all fx's. That means the set of all images. So suppose I have given you a function fx equals to x squared. What is the domain? What is the codomain? And what is the range? Now, what is codomain? Codomain is kind of a supporting set where you can find your output. The set where you can find your output. So if nothing has been provided to you, you will assume that your function is a real function from R to R. So the domain clearly, because I do not see any restriction here, I can take square of any number, right? So entire R is my domain. Entire R is my codomain because any real number can actually, in my input is real number, output will be real. But when I actually find out the outputs, I know that x squared is greater than or equal to 0. It will always give me a positive value. So I know that the range is R plus. You must have the knowledge of finding out domain, range of any given function, okay? Suppose your function is sine x. What is the domain? What is the codomain? And what is the range? Since I can take sine of any real number, the domain is the entire R. What is the codomain? If the input is real, the output, I will assume that the output will be real. So R is the codomain. But what is the range? When you will actually calculate sine of any x, sine theta, sine of any angle, any value, you will find out that it's always between -1 to 1. So the range of this function is -1 to 1. So as I've already mentioned sine x, let me talk about some more trigonometric functions here. Sine x, we've spoken of. Cos x. Similarly, cosine x. Any real input could be given to it. I would expect the output to be real. Now the range, again, when you will try to figure it out, it's going to be, when you will actually figure out cosine of, all possible x's, all the real numbers, you will see that it's never going below -1, never going above 1. So the range is the bounded and closed interval -1 to 1. Bounded and closed, again, very important term, but I would expect that to be asked not in the basic maths. Those terms and any real analysis related to it could be asked in the advanced section of maths. Tan x works a little differently. Tan x is equal to sine x upon cos x. So what happens is that between -π/2 to π/2, it is defined. And in fact, at every 2k plus 1 upon π/2, it will have some changes. So the domain is the entire R except for those points. Now, what points I have to exclude? I have to exclude 2n plus 1 times π/2, where n is an integer. So all the plus and minus points, okay? So n is not a natural number. We're taking it as an integer. So plus minus. So plus minus 3 π/2. you will have an issue there. So there, because it will become infinity. Tan minus pi by 2 is minus infinity. Tan pi by 2 is infinity. So that kind of a problem will happen. Okay. Codomain, since whatever is my input is real, I would expect the output to be real. Now, what exactly is my output? It could be any real number. This time, your function is not bounded by any values. As you can see, the graph that I have portrayed here, and of course, it will keep on, going like that only. So you will have at pi, you will have some change here, and then it'll move up, and so on and so forth. At pi by 2 with pi, and all these values, you will have that issue here. So, but all real values could be generated. Okay, all real values could be generated. As you can see, the graph keeps on going. Discussing about functions, let's talk about a very important function, which is your exponential function. Exponential function means that you have a base and a power to it, and the variable is in the power. So a to the power x. When the variable is in the power and variable takes different values, things grow or shrink exponentially. Okay. So a to the power x, where a could be except for 1, actually, it could be and negative. So it could be something, a fraction between 0 to 1, or it would be greater than 1. That's the function that we are looking at. Now, a to the power x, the domain, I can put any real number, be it positive, be it negative, be it rational, irrational, any real number. I do not have that kind of a restriction here. And I would expect the outcome to be positive, to be any real number. But when I will actually take out the outcome you will see is always positive. What will come out is actually just positive. So the range will become R plus. In fact, why don't we just graph this kind of a function? I've just tried to represent it graphically for you guys. You can take a value of A. The first graph is representing when A is greater than 1. You can think in your mind, maybe, you can think of 2, 3, anything feasible for you. When x will be equal to 0, you will definitely get 1 only. So the cut that you find will be at 1. And the graph will move like this. When a is between 0 to 1, this is an important point that I wanted to make so that some things are very clear in your head. That means it's a fraction between 0 to 1. So yes, when x is 0, you will get 1. So the cut here will be at 1 only, okay, on the y-axis. This point is a part of the graph. But the graph will look something of this sort. Think in your head as a as half. So when x is 2, half to the power 2. So that will give you 1 by 4. Then 1 by 8, so on and so forth. So you can see that the values are decreasing. So you can see that this graph is a decreasing one. This is indeed an increasing one, right? Similarly, if we talk about the log function, logarithmic function, a very important one. You can have natural log or some other base. Log base a x. That basically means when x is equal to a to the power y, I can say that y is equal to log base a x, right? What is the domain for log? Now, domain for log is basically R plus. And that's happening because log and exponential, they're inverse of each other. And in inverse functions, I will formally mention it again. But what happens? The range of one is the domain of other. So the range of exponential is the domain for log, right? So R plus, I can only take, in fact, R plus plus. I can only take strictly positive values as my input. But I do not know what values I will generate. It could be any real number. I know that it will be real in nature. So codomain has to be R. The range of log is again R. And that's happening because if you remember anything about log function, I hope you remember that log of 0 tends to minus infinity. And that's why you have a concave graph looking like this. When the base is anything more than 1, log graph would look like this. It will cut the x-axis at 1 because log of 1 will be 0. And log of 0 is actually coming from minus infinity. So log is negative. The value of the log is negative between 0 and 1, and then it becomes positive and moves up. It's a strictly increasing function, concave shape. When your base is between 0 to 1, then it becomes a decreasing function. And of course, again, it will cut the x-axis at 1, but the graph will be of this sort, okay? The greatest integer function, another very important function is the greatest integer function on which any teacher, any institute can test you. Now, when we say bracket, these kind of brackets and x inside, this means we're talking about what comes out is the greatest integer less than or equal to x, the greatest integer less than or equal to x. So if I have, say, 2.4 inside this bracket, what will come out is the greatest integer less than or equal to 2.4, and that integer is 2. If I will try to find out what is this bracket for 3.4 value, it will be 3. What is it for minus 2.4? The greatest integer less than or equal to whatever is inside the bracket. So which is that greatest integer? Integer which is less than minus 2.4. Is minus 2 lesser than minus 2.4? No. Minus 3 is lesser than minus 2.4. If you will see it on the number line. So graphically, if we will see this case, 0 is here, 1 is here, minus 1 here, 2 here, minus 2 here, 3 here, minus 3 here. Similarly, 1, 2, 3, minus 1, minus 2, minus 3. Well, when you have your input x between 0 and 1, what will happen? If it's 0, then 0 comes out. But if it is half, what is the greatest integer less than or equal to half? It's 0 only. What is the greatest integer less than or equal to, say, 2 by 3, which is also lesser than 1. So less than or equal to 2 by 3, the greatest integer is 0. So between 0 and 1, only 0 keeps coming, but the moment you will put 1, 1 comes out, right? So the value at 1 is not here. It's not 0. It's up here. And if you will see now, take any input between 1 and 2. Between 1 and 2, the input could be, say, 3 by 2, 1.5. What is the greatest integer less than or equal to 1.5? It's 1, of course. So for any number between 1 and 2, it will be just 1. But the moment I will put 2, 2 comes out. And up till 3, it will just be 2. So this is a step function, as you can see, and it for the negative numbers also, it will go like this. Between minus 1 and 0, if you take minus half, what is the greatest integer less than or equal to minus half? It's actually minus 1. So if my input is minus half, then minus 1 comes out. If it is anything apart from 0, this would come out, okay? At 0, you will have 0, but minus 1 for others. When minus 1 is the integer, is your input, then minus 1 comes out, okay? But then suddenly there will be a change. The moment you will go a little lesser than minus 1, you will get minus 2. So at minus 1, you don't get this. And then you will just keep getting minus 2. And similarly, anything lesser than minus 2, you will keep getting minus 3. So on and so forth. This will be a step function, a very important function for you to be able to analyze. Then comes another important function related to the greatest integer function, which is the fractional part. So I always teach my students this concept that any number could be actually written as a sum of its integer part and fractional part. For example, if you have say 1.5, 1.5 could be written as the greatest integer 1.5 plus the fractional of 1.5. So you will realize, what it is. The integer part is 1 and the fractional is 0.5. So we can define this curly bracket x I'm defining as the fractional part function. So fractional part function is the fractional part of any number, which we can actually define as x minus the greatest integer x. You take out the integer part from a number, you get the fractional. So 2.4. If you have 2.4, f of 2.4, that would be 2.4 is the number minus the greatest integer 2.4, which will be 2.4 minus 2, that gives you 0.4. What if the number is minus 2.4? What is the fractional value? So minus 2.4 minus the greatest integer of minus 2.4. Now the greatest integer of minus 2.4 is minus 3. So minus 2.4 minus 3, that will give you 0.6. So the fractional part is actually this time 0.6. Okay, so fractional part function gives you, it's a positive fraction between 0, 1. And if you're defining it using the greatest integer function, and that's how it generally is defined. Okay. Now, algebra of functions is something which is extremely important. It's a very basic thing for any examiner to ask you. Now, what does it mean? It means that when you have two well-defined functions, so f is a well-defined function on domain D1 to R, g is a well-defined function from domain D2 to R. These are two functions, and D is the intersection of these two domains, and it's not equal to phi. It does contain some elements. In that scenario, you can define f plus g, f minus g, f multiplied by g, f by g. And these will be well-defined function. You can define a domain for them. So how will you be able to define these functions? F plus g will be defined for D, which was the intersection of both the domains. Because ultimately, what does domain means? All the common x's, the x's that can satisfy all the conditions. So when you have f and g into consideration, all the conditions of f and g are getting satisfied in D, okay, which is the intersection of D1 and D2. So from D to R is your codomain. This would be your function. This is how you can define your function f plus g. Similarly, you can define your function f minus g like that. Similarly, you can define your function f into g. F multiplied by g can also be defined just like this. What you need to be very careful is with what exactly would be f plus g. F plus g would be defined as fx plus gx for all x. F minus g would be defined as fx minus gx for all x. F multiplied by g will be fx multiplied by gx for all x. That's what your function will be. Now, be careful when it comes to f upon g. The only thing that you have to be careful with is that the domain will basically be D, except for, you will have to exclude D minus all the x's where gx, your denominator is 0. You will have to take, because you cannot have 0 in the denominator, so you'll have to take those x's out. So you just have to be careful with that. And how you can define this function, just the way we have been defining them. So it will be fx by gx. And yes, the condition that we want is that gx is not equal to 0. And that condition I have taken up here. That's why I wrote D dash here. So for example, if we have, say, functions R plus 2R, F which is log x, and g is minus pi by 2 to pi by 2 tan x, tan x. So can we define f plus g, f minus g, f multiplied by g, and f by g? Well, so you would have to see whether all these functions are turning out to be well defined. Since they have defined tan x like that I don't have any problem in the domain. They've only taken the domain open interval minus pi by 2 to pi by 2 where tan x is well defined, right? So I do not see a problem there. The only problem that I see in the common domain, in the domain for log, I cannot take negatives. So, which means I cannot take negatives for the common domain f and g. So I can define all these functions. Where can I define it? I can define them in open 0 to pi by 2. I can define these functions in open 0 to pi by 2. All these functions are well defined in this domain, and you can take the codomain as R because ultimately you will get a real number. Types of function. What are the types of function? You must always keep in your mind the types of functions. You have onto function. Onto function means that no idle elements in the codomain, or in simple words, codomain is equal to the range. When your range turns out to be the entire codomain, then your function is said to be onto. That is, for each value in the codomain, you have a pre-image. Into function, a function which is not onto is called into. One function. One function, this is an important one in the sense you can be asked questions based on onto and one. One, please try to understand, as the name suggests, one element goes to one element. One element goes to one element in terms of mapping. There is still no restriction on the codomain. You can have some free elements, in the codomain which do not have a pre-image. That's okay. But you cannot have two pre-images. That means one means you have a unique pre-image. So, which essentially means that in case the images are equal, that means they must be coming from the same element. So basically, distinct elements in the domain are providing you distinct elements in the codomain. Or distinct pre-images are giving you distinct images. That's what. Bijection is another, if I put another restriction on one-to-one, that it has to be onto as well. So one, and onto, which would basically mean that, okay, in terms of mapping, yes, one element is mapped to one here. And you cannot have idle elements here. So there is one element back there as a pre-image. Okay. Once you are able to define bijection, you can very well define inverse for a function. Now, if say f is from A to B, we can define, then you can define G from B to A. This could be done by taking the inverse. But will I be able to take the inverse? If f is 1 and onto, then G is also 1 and onto. That's because ultimately what is happening is that every element here is associated to exactly one element here. And you sort of have a one-to-one correspondence. This is what is called one-to-one correspondence actually. So whether you go from this side to this side or this side to this side, it will not make any difference. And that's how you are able to generate inverse for any function. So in this case, G and F, they are inverse of each other, or we can say that F inverse is equal to G. G is nothing but F inverse. Okay, so what is happening here? When you take the composition, you get identity elements. Basically, f of f inverse x will just give you x. And f inverse of f of x will just give you x again. So that is happening. That is why you have an inverse here. Well, you could be asked different kind of questions from inverse. This is a very important topic from exam point of view. Again, that's what I'm discussing today. Fx is equal to root x. Say, if fx is equal to root of x, find f inverse of fx. Find f inverse of fx. Well, this would actually mean that I need to find f inverse of root x, because fx is actually root of x, right? But I need to know what f inverse will look like. In order to find f inverse, what do you actually have to do? Let me give you small working here. So when f is from A to B, what's happening? You have an x here and you get y, which is equal to fx here, right? Now, when you're going from this side to this side, B to A, what's going to happen? You have y here, okay? And since the operator is f inverse, what is happening? You will find f inverse y here, right? So that means that some x will be equal to f inverse y. How can I get this representation? You have fx equals to y. Now, if the scenario is in your favor and the inverse exists, x could be written as f inverse y. Okay. So how do you practically find it? Now put the formula of fx, whatever you have, and try to find x in terms of y. That's what we will do here. So we have y is equal to root x. If I square on both the sides, I will get y square equals to x. So clearly what I get is that x is equal to y square, which becomes your function. So y square is nothing but f inverse. The functional form is y square. So your input in case is y, the function will look like y square. If your input is x, f inverse x, the function will look like x square. And what do I have to find out? I have to find out f inverse of root x. So my input is root x. Root x square will be x. So hence the answer to this question will be x. Two another kind of functions that I would like to mention here, because again, it's very basic for them to ask you even functions and odd functions. Now, what is an even function? When you put the input as negative, you get the same value as you're getting for the positive input. Then that means the function is actually even in nature. For example, x square. If your input is -2, then also you get -2 square. If the input is 2, then also you get 2 square, which is 4. So both are 4, so they're equal, right? So it's an even function. What about an odd function? An odd function is when you take the input as negative. So f of -x, and it gives you negative of fx. Association is still there, and negative of fx is coming out. Then we call that function an odd function. Example, x cube. I know that if I take the input as -2 cube, and I take the input as 2, that is a positive of x cube, this will give me -8 and this will give me 8. The relation is there, the number is same, the absolute value is same, but positive negative is different. So this is an odd function. You must be able to actually visualize that if a particular function is given to you, whether it's odd, even, it can have its own consequences actually, apart from any direct question being asked to you on even and odd functions. It can have some implications in terms of maxima, minima. So it's easy to think in that terms. This was just a brush up of your little bit of pre-calculus as such. Calculus is something that now I'm going to talk about in today's video. Limits, continuity, and differentiability. What is limit? So there are many times you're not able to find the functional value at a particular point. You are interested in where is the function heading. For example, x squared minus 4 upon x minus 2. Yes, algebraically, this expression could be broken down to just x plus 2 by using a square minus b square. I'm assuming that you know the formula, right? You can break x square minus 4 as x minus 2 into x plus 2. And then in the denominator, you have x minus 2. So this x minus 2 cancels and you get x plus 2. But that doesn't mean that this function is defined at 2. This function is not defined at 2. So this expression could be broken up for all the x's which are not equal to 2. At 2, I cannot define this function. But what I can actually do is I can try to find out the value of this function as x is tending towards 2. You would realize graphically that whether you're coming from the left of 2 or the right of 2, graphically you are somewhere around 4, which is like 2 plus 2. So limit of this function is 4, we would say. That's the concept of limit. The value of the function is not 4. The limit for this function is 4. Limit talks about the journey of that function around certain point, not the destination. But the existence of limit depends on something which is called the left-hand limit and right-hand limit. As you must have heard me just saying that whether it is coming from the left of 2 or right of 2, the limit, the value of the function looks like 4. It is approaching 4. We will not say it's equal to 4. The limit is 4. So left-hand limit means that I am interested in what's happening on the left of 2. Okay, so the function, whatever our function was, on the left of it. So this is how in general you will write the left-hand limit is as x tends to a minus of fx. This can also be written as limit h tends to 0. The change is almost 0, but the change is towards the left. Okay, the change is towards the left, so we will deduct something from a. Okay, similarly you have the concept of right hand limit. That means we're interested in the on the right of 2 what is happening. Okay, so the limit as x tends to 2 plus, which basically means a plus for any general case, and that means we are interested in the right, on the right. So in terms of change, if I may write, it's the limit as h. The change goes to almost 0. It's a very small change. But what is happening with even with that small change? That is what we have to figure out. Okay. In case of this function, x squared minus 4 upon x minus 2. In case you look at this function x plus 2, whether you are a little less than 2 or a little more than 2, you're around 4. The functional value is around 4. So hence we would say that that limit exists. Limit for a function exists if and only if the left-hand limit, we call it LHL, at a is equal to the right-hand limit at a. Functional value may not be there at a, but the limits from the left and right have to be equal. If the limits from the left and right are different, we would say that this function, for this function, the limit does not exist. Okay. With respect to limits, the function that we just spoke of previously, the greatest integer function. This is a very important function to foresee with respect to limits. So let's find out the limit as x tends to 2 of this function, greatest integer x. For us to be able to say that the limit exists and it is there and it is whatever number that comes out, the value that comes out, I need to look for the left-hand limit and the right-hand limit, right? So left-hand limit will be as x tends to 2 minus of the greatest integer x, and the right-hand limit will be the limit x tends to 2 plus of the greatest integer x. Okay. Now, left of 2 would consist of numbers like 1.9 or something, right? You can keep an example in your head to figure it out that what's going to happen here. So suppose what exactly is x is 1.9. What is the greatest integer less than or equal to 1.9? Well, the greatest integer less than or equal to 1.9 is 1. So 1 comes out from here. When I'm talking about 2 plus means that a little more than 2. So maybe it is, my input is 2.1. If say my input is 2.1, what is the greatest integer less than or equal to 2.1? The greatest integer less than 2.1, that's 2. Well, in this scenario, my left-hand limit at 2 is not turning out to be same as my right-hand limit at 2, which means we have a problem. And what is the problem? The problem is that the limit does not exist. In this scenario, you say that limit as x tends to 2 fx does not exist. So existence at times becomes a very important thing to see for a particular kind of function. When it comes to limits, there are some very, very important formulas you must remember. Sine theta upon theta, as theta is tending towards 0, it turns out to be 1. The limit as theta tends to 0 of cos theta is equal to 1. We also say, of course, cos of 0, we take it as 1. The limit as x tends to infinity, 1 plus 1 upon x to the power x. This is a very important form. If you notice, if you put the value infinity here, you will see that you actually have 1 plus 0 to the power infinity. This is called 1 to the power infinity form. It's a very important indeterminate form. 1 to the power infinity in terms of limits, you cannot say that it is 1. The number 1, exact number 1, if you multiply it infinitely many times, you will get 1. But we are not saying it's exact 1. It is the limit 1. It is tending towards 1. It could be a little lesser or little more than 1. Okay. So hence it's indeterminate. Therefore, this is a very important indeterminate form. In fact, when you calculate it, you will get E. This is the limiting form for E. Limit x tends to a of x to the power n minus a to the power n upon x minus a. If you will put a in place of x, you will get 0 upon 0, right? But what it will turn out to be in terms of limit is n times a n minus 1. Looks like it's just a derivative of x to the power n as x is taking the value a. Well, indeed, but I'm going to introduce to you derivatives and then talk about it. A to the power n as n tends to infinity. It depends on what kind of a number is a. If a is a number which is more than 1, any number more than 1, if you keep on multiplying itself by itself infinitely many times, you will get infinity. If it is exactly equal to 1, this time the a is exactly equal to 1 and you're multiplying it infinitely many times, so you will get 1 only. But if it is a fraction between -1 and 1, a fraction between -1 and 1, if you keep on multiplying it by itself again and again infinitely many times, it is almost turning into 0. So that will be 0. And if a is less than -1, this limit will not exist. The concept of limit, please remember, in case limit exists, limit has to be unique. The concept of limit is associated to uniqueness, okay? Limit x tends to 0. Log of 1 plus x upon x, that is equal to 1. These are certain limits that you must actually remember, though you should know how to calculate it also. And most of them are actually indeterminate forms, and we use a specific method to find them. Now let's talk about continuity. So continuity, see what continuity means is that when I start drawing this curve, the pen never stops. There is a continuity, no break. So continuity just means that you have no break in the graph. It's a, if you think of it, continuity is a very graphical concept. So a function is continuous when the graph doesn't have a break anywhere. The function doesn't have a break anywhere. It's not that I have to always graph a function to figure out continuity. A function is continuous at a point A, if and only if the limit exists. The limit will exist when the left-hand limit is equal to the right-hand limit, and it is equal to the value of the function at that point. Okay, so LHL equals to RHL. And it is equal to the value of the function at that point. Okay, so then we say that the function is continuous also at this point, because what's going to happen here graphically, if you may see. So we started off with the function x square minus 4 upon x minus 2, and this is a function which is not well defined at 2. So this is equal to x plus 4, x plus 2 when x is not equal to 2. But if I herein I define the function at 2. If I define the function at 2 as 4, what's going to happen? The limit is 4 and the functional value at 2 is also 4. So graphically, there will be no break. Graphically, there will be no break. So what's going to happen is here you have 2, here you have 4. As x will be going to 2, the function will be going to 4. So the graph will not have any break. The function is defined everywhere. At 2, I thought there was a problem, but the moment I defined that at x equal to 2, the function is giving me the value 4. It's all sorted. It becomes a continuous function. You will not have any break. Similarly, you can think of some other function. So suppose fx is equal to 6 minus 5x. When x is between 0 and 3, and it is x minus 3 when x is greater than or equal to 3. The break point where some change is happening is 3. So I will be interested in whether this function is continuous at 3 or not. As x tends to 3 minus, that is on the left of, the function will take this form, that is 6 minus 5 into 3. So this will give you minus 9. On the right side of 3, the function will take this form. So it's going to be 3 minus 3, 0. Well, that means that the left-hand limit is not equal to the right-hand limit. The limit does not exist. From one side, I see that the function is minus 9, and from other side, I see the function is 0. The limit is not unique. You can see that the function is looking like something from left. You can see the function is looking like something else from right. In this scenario, if the limit only does not exist, how can the function be continuous? There is absolutely a break here. Okay. What you should remember about continuity are the properties, some very, very important properties. So suppose f and g are two functions which are continuous at a. Then f plus g is continuous. It will be continuous at a. F minus g will be continuous at a. F multiplied by g will be continuous at a. F upon g will also be continuous at a, given fx is, or given g of a is not equal to 0, because the moment g of a is equal to 0, then there's a problem, okay, in the existence of f upon g. These are some important properties related to continuity. Now let's talk about derivatives. Once you know about limits, you can talk about derivatives. Now, derivative of a function at a particular point is basically the change in one variable, the change in the dependent variable with respect to the change in the independent variable. So if y is equal to fx, then I can find out dy by dx. And that's nothing but the change in the function upon change in the input x, as the change is minuscule, almost tending towards 0. So if change in x is h, and as h goes to 0, I will be observing f of x plus h minus fx upon h. Change in f upon change in x. Change in f is, the new value is x plus h. So f at x plus h minus the previous value, which is fx. So that's change in f upon change in x. If this limit exists, then we say that the function is differentiable at this particular point x. And this limit, the existing limit, that is your derivative at this point. So the derivative for some important functions is something that I want you to write down alongside as a revision part. Derivative of sine x is cos x. Derivative of cos x is minus sine x. We can all use the method of first principles to figure it out, but these are something that you should remember by heart. Derivative of tan x is secant square x. The derivative of secant x is tan x secant x. The derivative of cot x is minus cosec square x. The derivative of cosec x is minus cosec x into cot x, just like, you know, tan x secant square secant x, the way it goes, just like that, okay? Now, the derivative of a to the power x, an exponential form like this, is a to the power x into log a. The derivative of inverse of sine is 1 upon square root of 1 minus x squared. The derivative of inverse of cos is minus of 1 upon square root of 1 minus x squared. The derivative of tan inverse x is 1 upon 1 plus x squared. The derivative of cot inverse x is minus of 1 upon 1 plus x squared. The derivative of secant inverse x is 1 upon the absolute value of x multiplied by square root of x squared minus 1. The derivative of cosec inverse x is minus 1 upon modulus of x into square root of x squared minus 1. Once you know how to differentiate, now in limits, I can introduce to you the very important, rule for indeterminate forms. Indeterminate forms are the major one. Two very famous indeterminate forms for which this rule exists is 0 by 0 and infinity by infinity. Now, when I write 0 by 0, what does it mean? It means that if you have a formulation in terms of fx upon gx, in which what happens is that f is also tending towards 0 and g is also tending towards 0, then 0 doesn't cancel out or something, and it is not even equal to 0, we can say. So this becomes a special form, an indeterminate form, which we can't determine at the face of it. So we have to work a little harder to find the answer to it. Similarly, infinity by infinity. For example, suppose you have that y is equal to limit x tends to infinity, x log of 1 plus 1 by x. Now, x times log of 1 plus 1 by x If you put infinity here, you will get that this is multiplying, this expression is multiplied by infinity, and this expression itself is log of 1 plus 0, 1 upon x, as x is infinity. So this becomes log of 1, that is 0. So this is like 0 multiplied by infinity. What I'm going to do is I'm going to change this form. Actually, this is also an indeterminate form. So there are in total 7 indeterminate forms. I hope you know about them. Log of 1 plus 1 by x. And what I can do is I can get that x down here and make it 1 by x. If you notice, it's going to be the same thing. It's 1 by x. If you will divide this expression, x goes up there only, right? So log 1 plus 1 by x upon 1 by x. And now as if you will view it as x goes to infinity, you are getting log of 1 upon x, which is 1 upon infinity. This is 0 by 0. In 0 by 0 form, we can use something called L'Hopital rule. This S is silent. You can write it or you can even ignore it. You can check it out. You can write also or you can ignore it also. You might not write it. It's L'Hopital rule. And what you can now do is, this rule says that limit x tends to whichever value. If you were looking at fx upon gx, this form in case is 0 by 0 or infinity by infinity. Then we can say that this limit is nothing but f dash at a upon g dash at a. This limit is nothing but f dash a upon g dash a. What is important for you to understand is that again, if f dash a upon g dash a also gives you the limit 0 by 0 or infinity by infinity, you can again differentiate and use this rule till the point you do not get your answer. So what do I have to do here? This is a 0 by 0 form. So I have to, this is my f, this is my g. I have to differentiate the numerator and differentiate the denominator, put the value x infinity. That's what I have to do here. So differentiating the numerator would mean that, so when you will differentiate, you will get 1 upon 1 plus 1 by x. Chain rule will play its role. So minus 1 upon x square. And the denominator, you have to differentiate separately. And this cancels out, right? This will cancel out with this. What are we left with? 1 upon 1 plus 1 by x. As x tends to infinity, now you will have to check what's going to happen. I'm just going to get 1. So the answer to this will be that y is equal to 1. We haven't used any operation here like log and all. So this is the straightforward answer that we will get. It's 1. The last thing for today is another application of derivatives. L'Hopital rule is one application, and another application for derivatives would be, if you see that the derivative of a function is always turning out to be positive, or it is positive in some interval, in say interval AB, then that would mean that f is increasing because the rate of change is positive. Hence the hence the functional values would be increasing in comparison to the previous ones. So f, we will say, is an increasing function in that case. In case the derivative is less than 0, that means f is decreasing. In case f dash x is equal to 0. Now that means some change is happening. Either the function is changing from increasing to decreasing, or it is decreasing and then increasing. And that is why at this point, you are getting f dash x equals to 0. This is a point where the function sort of stations itself. This is called a stationary point. This is a changing point, a turning point, and hence this is one of the points where you can fetch your maxima and minima. Extremely important point in terms of a differentiable function. You can find out maxima, minima, local or global for any particular function at a stationary point or a critical point. When the function is not differentiable, then we call it a critical point. At a turning point, you can find max min, or you can find it at the end points. So guys, this is an important takeaway from here. If your derivative is equal to 0, you're getting your stationary points there for that x. That means x is a stationary point, and there you will get your maxima, minima. Also, another application, and very, very important one, is when you differentiate your derivative once more. So when you differentiate your derivative function, that gives you the double derivative. Double derivative means that you're differentiating the same function twice. And when you differentiate a same function twice, you can actually figure out about maxima, minima, or you can figure out convex, concave, convexity or concavity of the function. That is the shape. You can figure out the shape or curvature of the function. So when you are talking about maxima, minima using the double derivative, you're actually just looking in the neighborhood locally. If you're talking about convexity, concavity, you are looking into the entire domain per se, or particular interval, not just a particular point. If your derivative, double derivative is positive, if your double derivative is positive at a point, at say A, if your double derivative is, I should not take A, B is the interval that I took as such. So let's take C as our critical or stationary point. So at the stationary point, if my derivative, double derivative is greater than 0, that means I will get a minimum. That means that the slope is an increasing one. The slope function is an increasing function, hence I will get a minimum. If the double derivative at this particular point is less than 0, then I will get a maxima, because the slope function is a decreasing function, so it will give me the maximum value here. Now, you are asked questions even in basic maths related to convexity, concavity, maxima, minima. So this is basic only. The double derivative, when you see it in the particular interval, if I'm seeing it in the entire domain AB, and I see that the derivative, the double derivative is greater than 0, that means my function is actually a strictly convex function. For example, x square or x to the power 4. The derivative, double derivative of such function is positive. If the derivative is negative, double derivative is negative, that will give you a strictly concave. In fact, for convexity, concavity, equal to 0 is also fine, but not for maxima, minima. Because when the double derivative is equal to 0, you can have all the three situations. Now, what are the three situations? You can have max, local or global, min, or you can even have inflection. So you have to check whether you have a maxima, minima, or inflection by using some other method, maybe higher derivative test, or maybe by looking at the values around this point C. Now, suppose we have fx equals to minus of e to the power minus x. What is f dash x? So f dash x will be the derivative of e to the power minus x is minus e to the power minus x with a minus sign outside, and we already had a minus. So there are two minus signs, so that means I'll have e to the power minus x, which means it's an increasing function actually, because this derivative is positive. Exponential, whatever is the power, is positive. Now the double derivative of this expression will be e to the power minus x Minus comes outside, which is less than 0. Since it is less than 0, what can I say? And this is less than 0 for all x, not just a particular x, for all x. So in the entire domain, for all x's, I have double derivative negative, which means it's a concave function, which means f is a concave function. A concave function looks like this or some other variation of it. Okay. Well, this is what I wanted to discuss with you guys in today's video, and we will brush up some more concepts tomorrow. See you guys. Hi guys, welcome to the basic mathematics revision video. Today, I'm going to start from the point that we left in the previous video. So this I'm calling revision part 2A. I'm going to start today's class with a question. Pause and solve that question for yourself. X is equal to 1 plus y to the power minus 4 and y is equal to minus 2 times log t. You need to find out dx upon dt, dx by dt. How will we reach to dx upon dt? What we know is we can clearly see that x is in terms of y. We can clearly see that y is in terms of t. So how can we relate in terms of derivative x and t? Dx upon dt will actually be dx by dy into dy by dt, right? So you have to calculate the derivative of x with respect to y, the derivative of y with respect to t, and just multiply the two. Clearly, the derivative of x with respect to y is minus 4, 1 plus y to the power minus 5, minus 4, minus 1, right? And the derivative of y with respect to t is minus 2 upon t. So that means what's going to happen is the product will be 8 times 1 plus y to the power minus 5 upon t. Now, since y is equal to minus 2 log t, you can make this substitution out here and you can say that dx by dt is 8 multiplied by 1 plus turns into minus because y is minus 2 log t to the power minus 5 upon t, or in other words, it is 8 upon t multiplied by 1 minus 2 log t. And that's how you can answer this question, okay? Now, in terms of derivatives, there's another concept that I would like to discuss with you, which is a question that you could be asked upon, and that is derivative of inverse. So kindly remember that derivative of inverse, how to find it out. Y is equal to fx and say x is equal to gy, and they're inverses of each other. So say fx and gy, they're inverses of each other. That essentially, that would essentially mean that g is nothing but f inverse. Okay, we've spoken about inverse functions, so you should know about it. Now the derivative of g, that is the inverse, at the point y would actually be inverse of the number which is derivative of f at x. That is, g dash y is equal to 1 upon f dash x. Since this is the kind of relation that you have, which the invertible relation, okay? So in other words, we can say that f inverse derivative at y is nothing but 1 upon f dash x. So in terms of how to solve a question when, this is something that is asked to you, I'm going to give you an example. Suppose fx is equal to x to the power 5 plus 2x cubed plus 7x plus 1. And you are able to find out inverse. This is an invertible function. You are able to find out inverse. So y is equal to fx. That means x is equal to f inverse y. Okay. So these two things are with us. We need to find out in this question f inverse derivative at the point 1. What will be the derivative of f inverse at the point 1? Let's start with it. Now, when you are talking about f inverse function at a particular point, this point is a y value. So you should first of all try to figure out for this y value, what x do you have? Can you see any x for which you get y as 1? Well, I can straightforward see that if I will put x equals to 0, my fx or y will be equal to 1, right? So I know that when fx is x to the power 5 plus 2x cubed plus 7x plus 1, this would be equal to 1 in case x to the power 5 plus 2x cubed plus 7x is equal to 0, and that will clearly happen when x is equal to 0. So x is equal to 0 is a case where your fx will be equal to 1, or in other words, f of 0 is equal to 1. So please see to that. That's the kind of invertible relation you have. 0 input is giving you 1 as output. Okay. So that means 1 could be taken back to 0. Okay. That's the invertible relation. So according to what we wrote for derivative of inverse, the derivative of inverse is inverse of derivative. The derivative of inverse is inverse of derivative of the original function at the corresponding x value. So the corresponding x value is f inverse 1. The corresponding x value is f inverse 1. Okay. So 1 upon f dash at f inverse 1. Now, what is f inverse 1? F inverse 1 is 0, because that's the relation we have. F of 0 gives you 1. So f inverse 1 gives you 0. So f dash at 0. Kindly calculate f dash and put x equal to 0 and you will get your answer. F dash in this case will be, since the function is x to the power 5 plus 2x cubed plus 7x plus 1, f dash x will be 5x to the power 4 plus 6x squared plus 7. So that means f dash at 0 will be equal to 7. So which means my derivative of the inverse function at the value 1 is 1 upon 7. And that's going to be your answer. So that's about derivatives today. I'm going to now move on to some equations. I want to discuss quadratic equations in details today. A quadratic equation looks like ax squared plus bx plus c. When you equate it to 0, it becomes an equation. If you just write down this expression, this is a quadratic polynomial. When you equate it to 0, it becomes an equation. Now, some of the roots, if say alpha and beta, 2 roots are there. At max, you can have 2 roots because the degree of this polynomial is 2. Degree is the highest power that x carries, right? Now, the sum of the 2 roots, that is alpha plus beta, is minus b upon a, and product of the 2 roots, that is alpha into beta, is c upon a. When you equate it to 0, then there has to be some x which is solving this equation. Equation as in, when you put that x, you will get fx equals to 0. Fx would be equal to 0 when x is equal to minus b plus minus square root of b square minus 4ac upon 2a, the whole thing upon 2a. And this is called a root of f. So you can have 2 roots, we're saying alpha beta. So this is how you can calculate alpha beta. Now this expression that you see inside the square root, this expression is called discriminant. And it plays a very important role in order for us to be able to find out the nature of it. It would totally depend on what kind of the value you are generating inside this square root. Suppose we have ax square plus bx plus c equals to 0 and alpha beta are two roots. Let's take the cases and figure out what is the nature of these roots under what conditions. If ax squared plus bx plus c is equal to 0, the notations that I've used here are different. I'm using lowercase here. It doesn't really matter. I'm doing it deliberately. You should be, judicious enough to figure out. It's just that these are coefficients. It's coefficients associated to the power of x. So you should know the formula by heart and then put the values, no matter what the values are. D stands for your discriminant and it is b square minus 4ac. Now, this discriminant might be 0, might not be 0. What happens when the discriminant is 0? What happens when the discriminant is not 0? When the discriminant is 0, the roots are equal. So when discriminant is 0, the roots are equal, and when discriminant is not equal to 0, the roots are not equal, unequal. Now, equal root would basically mean that alpha is equal to beta, and that will turn out to be equal to minus b upon 2a, because the discriminant part is 0 now, okay? Now, when the roots are unequal, what can happen? There could be two scenarios falling in. The first scenario is where your A, B, C, they're real numbers, and D, the discriminant is strictly greater than 0. And the second scenario is A, B, C are real numbers, but the discriminant is strictly less than 0. So when discriminant is strictly greater than 0, the roots are real. And when your discriminant is less than 0, the roots are imaginary. Imaginary would mean that you'll have complex numbers. You can't represent on the real line. Now, when roots are real, there could be two cases again. It might be the case that A, B, C, they're rational numbers, and D is a perfect square. When D is a perfect square, what happens then? The roots are rational. And the second case is that A, B, C, they're rational, and D is not a perfect square. In case D is not a perfect square, then roots are irrational. So, irrational roots will be of the form that you have P plus, say, root Q, P minus root Q, these kind of expressions you will have. Now, I'm going to show you diagrammatically the cases that you have for quadratic equations. The first case I'm taking is where roots are real and distinct. When you have distinct and real roots, the case for A is the coefficient of x square. This is a particular case of A and particular case of the discriminant. The particular case of A is that A must be positive here and D must be positive. So when A is positive and your discriminant is also positive, basically you will have this kind of scenario where x-axis is being cut 2 times. You have roots which are real and distinct. On the real line, you will have 2 distinct values. And then there could be second scenario where roots are equal. When roots are equal, that means it is going to just touch the x-axis. Fx is equal to 0 at just one point. When will this happen? This will happen. This scenario that you see will happen that your shape of the quadratic polynomial, it will be totally above the x-axis. Fx is only positive. And therefore, your A has to be positive. And your D is equal to 0 because you have equal roots. Okay. For that, D has to be equal to 0. When A is greater than 0, the quadratic polynomial, it will give you positive values. Now, the third case where roots are imaginary. When will the roots be imaginary? In this scenario, look at this diagram. Again, your fx is positive. Your fx is positive, that means A has to be greater than 0. And since your roots are imaginary, that means D should be less than 0. Simple. Roots are real and distinct again, but the shape of quadratic is like this. It's an inverted parabola situation. So which means that A has to be negative, but you have real and distinct roots. That means what's going to happen? D has to be strictly greater than 0. The next scenario is where you have again inverted parabola and the parabola is touching only at one point. That means you have equal roots. Equal root means D is equal to 0. Equal roots. And since you have inverted parabola, that means you have negative values actually of f. And that's going to happen when A is negative. Similarly, we'll have another case where roots are imaginary, but the scenario is looking like this. Your parabola is somewhere far from the x-axis because you cannot find out the roots on the real line. Okay. They're imaginary roots. So therefore, A is less than 0 because fx's are negative and D is also negative here. That's why you have imaginary roots. So diagrammatically, this is the scenario for quadratic. I hope with this knowledge now, you will be able to solve any quadratic question given to you. And these are the kind of questions you do get in your exam. What I would like you guys to do, whatever I've taught you yesterday, today, whatever I'm discussing, your task is to at least before the exam, do 2-3 questions of each of these topics. I think you can do that much for yourself and help yourself to be more prepared for these entrances, for any entrance actually which would ask you basic mathematics. Now, let me ask you a question. You must pause and solve, okay? Fx is equal to ax squared plus bx plus c, where a is not equal to 0. F of 5 is minus 3 times f of 2, and 3 is a root of fx equals to 0. So you have enough information. You already have one root. What is the other root for this quadratic equation? That's what we have to do. So let's get started. Now let me see if you understand the meaning of it. 3 is a root of fx equals to 0. What does it mean? 3 is a root implies that f at 3 is giving you the value 0. And if the form of the polynomial is ax squared plus bx plus c, that means a into 3 squared plus b into 3 plus c is equal to 0. So I have an equation with me, which is 9a plus 3b plus c equals to 0. I have additional knowledge in this question, and that is f of 5 is equal to minus 3 times f of 2. F of 5 means wherever you have x, just put 5. So you will have 25a plus 5b plus c is equal to minus 3 times f of 2 means wherever you have x, put 2. So 4a plus 2b plus c. Let's solve it. 25a plus 5b plus c is equal to minus 12a minus 6b minus 3c. Taking everything to one side, you will realize you have 37a plus 11b plus 4c equals to 0. Say this is equation number 1, say this is equation number 2. All we have to do is solve these two equations. Let's see what we get. Solving equations is a very important part of basic maths. So with this question, I'm also dealing with that. So I'm going to use elimination method. I want to eliminate c, so I am going to multiply this equation, which is numbered 1, by 4. So that I have 4C and I can eliminate it. So you have 37A plus 11B plus 4C equals to 0 stands as it is. The other one turns into 36A plus 12B plus 4C equals to 0. Now, if you subtract 4C will cancel out and you will be left with A, and from here minus B equals to 0. Well, that would imply that A is equal to B. If A is equal to B, what is the scenario? Now, this is a very important relation that we have figured out. We know that sum of the two roots is equal to minus B upon A. Well, that's the notation that we have. The middle term is B and A here. So minus B upon A, right? And that sum, that means, is turning into minus 1. That sum is equal to minus 1. And you know that, suppose this is alpha plus beta, and you know that alpha is equal to 3. One root is 3. Alpha plus beta is equal to minus 1 is only possible in case beta is equal to minus 1 minus 3, that is minus 4. So the other root is minus 4. Now, in case it will be an MCQ, I'm sure one of the options would be minus 4 and you can mark it. With this question, I would also want to give you some basic knowledge about cubic equations and biquadratic equations. So I would want you to write it down. A general form of cubic equation looks like ax cubed plus bx squared plus cx plus d equals to 0. And if the roots of this equation, the maximum number of roots that you can have is alpha, beta, gamma, that is 3 roots. Since you have n equals to 3, so you have, say, alpha, beta, gamma roots. Then you can find out, given this equation, you can find out sum of the roots, product of the roots, and sum of the product of 2 roots. Okay, so alpha plus beta plus gamma, that will be equal to minus b upon a, where ax cubed plus bx squared plus cx plus d is your equation. Okay. Alpha into beta into gamma is equal to minus d upon a. And alpha beta plus beta gamma plus alpha gamma is equal to c upon a. So kindly note it down so that if you have any direct question, you can work it out. Similarly, in biquadratic equations, what's going to happen? You have a general form of equation where the highest power is 4 biquadratic. ax4 plus bx cubed plus cx squared plus dx plus e is the general form of the biquadratic polynomial. Equated to 0, it becomes an equation. If the roots of this equation are alpha, beta, gamma, delta, since n, that is the degree, is 4, so you at max can have 4 roots, right? So suppose these are the 4 roots that you have. Now, again, you can find out the relation between roots and the coefficients. So alpha plus beta plus gamma plus delta is minus b upon a. You can find out the product of the entire number of roots, that is alpha, beta, gamma, delta. That's e upon a, the constant term upon the first term. You just have to be very careful with plus minus, okay? Then you can talk about the product of, the sum of product of 2 roots and also of 3 roots here, since you have 4 roots, right? So what permutations can you make? Sum of product of 2 roots at a time, alpha beta plus alpha gamma plus alpha delta, plus beta gamma plus beta delta plus gamma delta. So that will be C upon A. Alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. That will be equal to C upon A, coefficient of x square upon the first coefficient. And similarly, you can also talk about alpha beta gamma plus beta gamma delta alpha gamma delta. That is the product, sum of the product of three roots at a time. That will be minus b upon a. Well, these are basic relations that you should know about the coefficient related to the sum product of roots. And now I will talk about some geometry and mensuration. So geometry first. When we talk about geometry, the first thing that you should actually be comfortable with are lines. What are lines? What are line segments? So, a line, basically a straight line, is the shortest distance between 2 points. You make 2 points, the shortest distance between 2 points. It has no angles. It is infinite. A line can keep going on and on. When you have a finite line, it is called line segment. It is one-dimensional. It keeps on going in one direction. Sum of all angles in a straight line will be equal to 180 degree, because that's what is a straight line all about. Now let's talk about parallel lines. When do you say that two lines are parallel? When two lines are lying on the same plane, but they never intersect, then they are called parallel lines. The only possibility that they do not intersect is when they're moving like this. See, if the angle or slope of the lines will be different, they will definitely intersect somewhere. Either like this, or it could be a case where they're intersecting first and then moving ahead like this, diverging like this. So the only possibility that they are parallel is when they never intersect with each other. That's how you define parallel lines. With parallel lines comes another terminology, that is transversal. Now, what is transversal? So when a straight line intersects two parallel lines, when a straight line intersects two parallel lines, as shown here, and what you can see, you have two parallel lines and one line is intersecting. Then this is called transversal, and it has some following conditions. Please write down these conditions, extremely important for you to know. Points that you need to note. So these are the angles I've marked, A, B, C, D, E, F, G, H. Okay. The points are: number one, corresponding angles are equal. Now, what are the corresponding angles, guys? A, E. They are corresponding. See, A, E, G, C, D, H, B, F. So, what do you know here? A is equal to E, B is equal to F, C is equal to G, and D is equal to H. That's what you need to keep in your mind. Now, similarly, alternate interior angles are equal. Alternate interior angles are C and F. So that is somewhere here. Let me just use another color. This C and F, they're alternate interior angles. They're equal. So you have C equal to F. Similarly, just like that, D also is equal to E, as you can see here, D and E. Now, alternate exterior angles are also equal. Now, alternate exterior angles would be A and H. So you have A here. So if you see A and H, they are alternate exterior angles. They are also equal to each other. So A and H, and similarly B and G. So A is equal to H and B is equal to G. What else should we know? Interior angles on the same side of the transversal are supplementary angles. What are supplementary angles? whose sum is equal to 180 degrees, right? So kindly remember, you have angles on the same side of the transversal. That means CE should be 180. What else should be 180? DF, the sum of that should be 180. So interior angles, we are just talking about interior right now. So that is C plus E is equal to D plus F, and that's equal to 180 degree. Okay. Also, straight line angles are supplementary. So if you have any line like this and some line segment cuts it like this angle plus this angle will be 180. So that means in the case of the diagram that I gave you, A plus B is equal to C plus D, the markings were like that, is equal to E plus F, and that's equal to G plus H, and all of them, all the sums are equal to 180 degree. That will always happen. Another point that I want to make here, suppose you have a scenario where you have three parallel lines and three transversals. Then the ratio of the intercepts, that is the intercept A upon the intercept B, is same as the ratio of C and D, and this should be same as the ratio of E and F. So A upon B is equal to C upon D is equal to E upon F. Always remember that the ratio of intercepts of three transversals on three parallel lines is equal. And with this, we will move on to another concept. Now we know about lines, line segments. Let's talk about connecting three line segments to create a triangle. And when a triangle is created, what happens? So what is a triangle? It's a polygon with three sides. Some important points that we must remember about triangles. The sum of the interior angles, it needs to be equal to 180 degree. The angle opposite to the longest side will have the greatest angle. And on the other hand, the angle opposite to the shortest side will have the smallest angle. So if you have a scenario like this, it seems like this is the longest side. The angle opposite to the longest side is the largest. And it seems like this is the shortest side. So the angle opposite to the shortest side is the smallest. Okay. The third point, sum of two angles is greater than the third angle. Always remember this point. And apart from this, another important point, difference between two angles is always smaller than the third angle. So sum and difference, both the things you should remember. For your knowledge, what are the type of triangles you can have? Acute angle triangle, obtuse angle triangle. Acute angle triangle is a triangle where all the three angles are less than 90 degree. An obtuse angled triangle is a triangle where one angle is obtuse. Right angle triangle, clearly you have right angle involved. So one of the angles is right angle. Okay. Equilateral triangle, that means all the three sides are equal. So all three sides are equal. That's an equilateral triangle. So all three sides are equal. It would be a common side, say A. So what is area of an equilateral triangle? Always remember the area of an equilateral triangle is √3 upon 4 A square, where A is that equal side, okay, the length of that side. Isosceles triangle. An isosceles triangle is where you have two sides are equal. So say these two sides are equal. That's an isosceles triangle. Area of an isosceles triangle is C upon 4 square root of 4a square minus c square, where a is the common side as in two sides, two equal sides, and c is the unequal one, length of the unequal side. Okay, so that's an isosceles triangle. Now, what in general is area of a triangle? Area of a triangle is half into base into height. Okay, and I would also like to comment upon a very important formula, that's your hero's formula. So by hero's formula also you can find out area. And area of a triangle turns out to be S minus A, S minus B, S minus C, where S is A plus B plus C, where A, B, C are representing the sides, okay, length of the sides, upon 2, okay? And that's your hero's formula. Let's work on an application related to triangles. So suppose I give you 3 vertices, A, B, C, and I'm giving you points in 3D. So all these points are from R3. You know A is 1, minus 1, 2. You know B, it is 2, 1, minus 1. C is 3, minus 1, 2. If I want you to frame a triangle ABC and find its area, how would you go about it? So the question is about finding area of the triangle ABC for which vertices have been provided to you. You will find out the distances AB, BC, and AC. I'm sure you know the distance formula. The distance formula is the square root of x1 minus y1 whole square, or a. Suppose the points into consideration are x1, y1, z1, x2, y2, z2, x3, y3, z3, then the distance formula, say d, is equal to the square root of, just the way you find out distances in 2D. So it will be between 2 points, right? So suppose this is A and this is B. Actually, I don't need to take the third point. Let me just take 2 points. So the distance will be x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square and the entire square root of it. So we will use this formula and find out the length of AB, the length of BC, the length of AC. You will figure out length of AB is root 14, length of BC is root 14, and length of AC is root 4, that is 2. Which means it's an isosceles triangle. I just gave you the formula of area of an isosceles triangle. It is C upon 4 into square root of 4a square minus c square, where c is the unequal side and a is the length of the equal side. Putting in the values, you will get c is 2. So 2 upon 4, square root of 4 into 14, 14 square, root 14, so 4 into 14. So root 14 square is 14 minus 4, that is 2 square. So this will give you, if you take root 4 common, so you'll have 2 outside. So 2 upon 2, that cancels. This will be basically 2 here. And square root of, you will be left with, since you've taken root 4 common, so you will be left with 14 minus 1, that is root 13. And that should be the correct answer for this question. With this question, I want you to note down certain formulas related to mensuration. What is mensuration? It is all about evaluating and calculating suitable formulas to actual measurements of geometrical concepts like length, area, volume. All this is a part of mensuration. Now, let's talk about certain shapes. First of all, a rectangle. Perimeter of a rectangle is twice of length plus breadth. Area would be length multiplied by breadth. Area of a square would be, if A is the side, all sides are equal. So A square is the area and 4 times A is the perimeter. Perimeter is basically the sum of all the boundaries that you have, the length of the boundaries. Area of a triangle is half of height into base, and sum of the sides x plus y, x plus y plus z, if that's the length of the sides, then the a, or a plus b plus c, that is the length, then that's what will be the sum of perimeter. The sum will be the perimeter. Parallelogram. So parallelogram, when you join parallel lines, two parallel lines joined with another pair of parallel lines. A rectangle is also parallelogram, but any other shape also, but with constructed with parallel lines. That's a parallelogram. And the area of a parallelogram is A into L, where L is the height and A is the side. Now, your perimeter is twice of the lengths, sum of the lengths, different lengths. So if this is B length, this is A length, then A plus B and twice of it, because the opposite two are also the same. Rhombus, perimeter is 4A, and area of a rhombus is, if you have diagonal 1, diagonal 2, then half into diagonal 1 into diagonal 2. Quadrilateral is any four, if you have 4 sides, so quadrilateral turns into that. Sum of all sides is your perimeter. And the area is square root of S minus A into S minus B into S minus C into S minus D, where S is the sum of all the sides, A plus B plus C plus D, holding upon 2. Okay. Trapezium, sum of all sides is the perimeter, and area is half into height. Height will be this 90 degree that you will calculate, and base is A and the other side is B, so sum of that A plus B. Circle, extremely important, and the next topic that I'm jumping on to. Circle, the perimeter is 2 pi r and the area is pi r square. Let's talk about circle now. What is a circle? So you have a fixed point. Circle is locus of a point which moves in a plane. So its distance from a fixed point, which I'm taking like here is your fixed point, in the plane is always constant. So it moves such that this distance will always remain constant. And this distance is what we call the radius. And the fixed point is your center. The fixed point is the center. And it's the locus of a point which moves in a plane such that the distance from the fixed point, it never changes. Radius is fixed, right? So this fixed point, say HK, it's the center, and the constant distance, it's the radius. Now, equation of a circle looks like x minus h whole square plus y minus k whole square is equal to r square, because that's what it is. No matter which point you will take here, say this is what is your xy, and that's the center. The distance is fixed, right? The distance has to be r. So the distance formula is being applied, nothing else. The distance formula is square root of x minus h whole square plus y minus k whole square. That should give you r, right? Squaring on both the sides. This is the equation that you get for the circle. If it's a circular shape, it needs to satisfy this equation. If the center is the origin, that is 0, 0, then your equation of the circle will simply look like x square plus y square, because h and k, they're 0, is equal to r square. Suppose x1, y1 and x2, y2 are endpoints of a diameter, that is, line segment joining these 2 points is actually the diameter. Then in that case, the equation of the circle will look like x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. Point number 4 that you should remember, the general equation for any circle would look like x square plus y square plus 2gx plus 2fy plus c equals to 0, where f, g, c, they're constants, okay? They're just constant values. Number 5, and in fact, okay, let me just give you some more idea here. So f, g, and c, they are just constants. Center of the circle, in this case, the center that means is minus g minus f. The radius, in this case, would be square root of g square plus f square minus c square, where g square plus f square will be greater than or equal to c. Point number 5 to note, very important, equation of a tangent to a circle x square plus y square plus 2gx plus 2fy plus c equals to 0 at a particular point, say x1, y1, is x1 plus equation of a tangent to this circle x square plus y square plus 2gx plus 2fy plus c equals to 0 at a particular point x1 comma y1 is x into x1 plus y into y1, g times x plus x1 plus f times y plus y1 plus c. An equation of a normal, that was equation of a tangent, equation of a normal at a point x1 comma y1 will be y minus y1 upon y1 plus f equals to x minus x1 upon x1 plus g. And in case the circle that we're looking at is with the center, in case the circle we're looking at is with center 0, 0, so x square plus y square is equal to r square. And the point is x1 comma y1, the equation of the tangent will automatically turn into x into x1 plus y into y1 equals to r square, and equation of the normal will turn into x upon x1 equal to y upon y1. That's it from me today, and we will definitely work upon certain questions and some more concepts in the next video. Thank you. Hi guys, welcome to the next lecture. Today, I'm going to carry forward the basic stuff that we were talking about yesterday. I was talking about circles when we ended yesterday's lecture. So coming back to circles, a circle, as I said yesterday, it's the locus of a point which moves in a plane so that its distance from a fixed point in the plane is always the same. Okay, so this distance, which is your radius, it's always, the radius remains the same. Okay, P is a moving point and the constant distance is your radius, and from the center we are looking at. So what's the equation of a circle? Equation of a circle is that the distance is the same. So using the distance formula, you can create this equation of the circle. Suppose the center is h comma k and this point P is x comma y on the plane, then the distance between these 2 points is fixed no matter what xy takes the value. For any xy, you have that x minus h square plus y minus k square is equal to r square, keeping in mind the distance formula. So r is equal to the square root of x minus h square plus y minus k square. So when you will square on both the sides, this is what you will get. And this is happening for all xy, which are satisfying this equation. Okay. Now you can also think in terms of parametric form. Now, what is a parametric form? Parametric form is where sine theta, cos theta, angle comes into consideration. So suppose C is your center, and from understanding point of view, I'm taking the center as 0, 0, so that the situation for us simplifies and the circle becomes x square plus y square is equal to whatever your radius is, r square. So suppose C is the center, 0, 0. A is the radius. P is the point on the circle, which is x, y. Those are the coordinates of P. If you construct, say, a perpendicular, which is cutting the x-axis at M, and then look at PCM, this is a right angle triangle. PMC, it's a right angle triangle, where you can easily see that CM, since this point is x, y, so CM is the x-axis value, so it is x, and PM is the y-axis value at this point, so that's y. Now, sine theta, we all know, if we have a right angle triangle, this much trigonometry we should know. Sine theta is equal to perpendicular upon hypotenuse. Now, perpendicular length is PM upon hypotenuse, which is your radius A. So what can I say about PM or y? This implies y is equal to A times sine theta. This is a parametric form coordinate. Similarly, cos theta is base upon hypotenuse, so it will be CM upon A, which means that x is equal to A cos theta. So your coordinates x and y could be written as A cos theta, comma, y could be written as A sine theta. This is what is xy in parametric form. A general equation for a circle is x minus h square plus y minus k square equals to a square. Hk is the center. Or if you open this up, you will get x square plus h square minus 2 hx plus y square plus k square minus 2 ky minus a square equals to 0, taking everything to one side. And then what I've done is I've taken x square y square here, then term with x, term with y here. And this is your constant term, right? Which is basically of the form x square plus y square plus 2gx plus 2fy plus c equals to 0. So say this is 1, this is number 2. If you solve the 2, what you will get that h is, if I keep this as my general form, I can say that h actually is minus g and k actually is minus f, okay? A is square root of, it's the radius, A is the square root of g square plus f square minus c. So g square plus f square should be greater than or equal to c. That becomes a general condition for square root, okay? Now center, that means is minus g comma minus f. Radius is square root of g square, square root of g square plus f square minus c. Now, how to find center and radius? Let me give you a couple of steps which you can always use, and then we will move on to an application also. Make coefficients of x square, y square equal to 1. That is, if you have, say, 2 with x square, y square, you can just divide throughout, okay? And the right-hand side equal to 0. So take everything to one side. With that, you'll be able to relate. So your center HK is nothing else but, if you notice, it is minus of half of the coefficient of x. And K is nothing but minus of half of the coefficient of y. Radius is h square plus k square minus the constant term. That's its square root of that. Now, let's understand this using an example. Find the center and the radius of the circle given to you as 2x square plus 2y square plus equal to 3x minus 5y plus 7. The first thing that I will do is I will take everything to one side. So first I've taken everything to one side, then I've divided throughout by 2 so that I don't have anything, the coefficient of x square and y square is 1. Once you've done that, now what you can do? You need to find the center. Center, we realized, is your h is minus half of coefficient of x. So it's going to be minus half of minus 3 by 2. So that's going to be 3 by 4. K is equal to minus half coefficient of y, which is equal to minus half, and coefficient of y is plus 5 by 2. So that's going to be minus 5 by 4. So your center is 3 by 4, comma, minus 5 by 4. That's your center. What's the radius? Radius, as I mentioned, is the square root of h square plus k square minus the constant term. So it's going to be square root of 9 by 16 plus 25 by 16 minus the constant term. Now, what's your constant term? The constant term is 7 by minus of 7 by 2. So minus minus plus 7 by 2. You will have to take the LCM, and that's going to give you 9 plus 25 plus 56. 7 multiplied by 8 and 16 here. So 4, of course, can come out. It's going to be 3 root 10 upon 4. That's your radius. Now, extremely important from examination point of view is equation of a tangent to a circle. Now, what is a tangent? Tangent is a line. It's a straight line, right? It's a straight line. So what will be its form? It's going to be of the form y equals to mx plus c. If we want to find out equation of the tangent, that means I would require the value of this m and the value of this c, right? So you need m and c. How do we find it? Let's first find m. We know that we are dealing with a circle here. So we will have an equation of a circle, and m is the slope of the tangent, right? Let me take an example so that it will be more clear to us, instead of giving you just a general case. Find the equation of the tangent to a circle, say x square plus y square equals to 25 at the point 3, minus 4. So at the point 3, minus 4 means that this is a tangent to this circle at this particular point, which means if I am creating a circle with radius 5, center 0, 0, because this is what the equation given to you tells you, x square plus y square equals to 25. Now, the tangent is at 3, 4. 3, 4 will lie somewhere here. X-axis value is 3 and y-axis value is minus 4. So 3, 4 is somewhere here. And we want to find what is the equation of this tangent, for which I need the slope of this tangent. I need the constant c. What I can see here is, if I take this point P, which has the coordinates 3, 4, from here, if I will join, I can create a perpendicular to the radius. This is a perpendicular from 3, minus 4 to the center, which is the radius. This is to the center. Now you have 2 points, O, which is your center, and P, which is a point here. You have coordinates for both these points. You have 0, 0 is the center, and the coordinates for P, 3, minus 4. Given 2 coordinates like this, can you find out the slope of this line, which is perpendicular to the tangent? Yes, of course I can. 2-point slope formula. Change in change in y upon change in x, right? That's what you have to find out. The radius OP is the perpendicular to the tangent. Now, what is the gradient of OP or the slope of OP? It's change in y upon change in x. I'm calling it M1. You've got 2 points. For OP, you have the coordinates of O, you have the coordinates of P. So 0, 0 and 3, minus 4. What is M1? Change in y. Change in y is minus 4 minus 0. Change in x is 3 minus 0. That means minus 4 by 3 is what you get. as the slope of the perpendicular that you have, the perpendicular to the tangent. Now, if two lines are perpendicular to each other, do you know the relation between the slopes? Yes. M1 into M2 will be equal to -1, right? The condition of orthogonality. Since tangent is perpendicular to OP, that means the slope of the tangent is M and the slope of the perpendicular is M1. This should give you, the product should give you -1, which means M is nothing but -1 upon M1, which will give you 3/4. So the slope of the tangent with this method you have figured out, it is 3/4. Great. Once you have the slope of the tangent, you can clearly figure out the equation. Why? Because I wanted to know what is M. I have M. Now I need C. Once I have C, then I can easily create y equals to mx plus c. How will you find C? Now this point, 3 comma -4, it lies on the tangent, right? It lies on this. And I have M. So I know y equals to mx plus c. And I have x and y to put in this equation. If I do that, I know M, I have x and y. When I will put it, I can figure out what C is. So let's do that. 3 comma -4 lies on y equals to mx plus c, which basically means that -4 is equal to 3/4 into 3 plus c. And that's going to give you C equals to, therefore, now that you have your C, which is equal to -25 upon 4 after the calculations, y is equal to M, that is 3/4, x minus 25/4. So you can say that you have the equation of the tangent is 3x minus 4y is equal to 25. Let's check if you've understood this concept or not. This time, let's take the equation of the circle as x squared plus y squared minus 6x minus 2y plus 2 equals to 0 and find the tangent at the point 1 comma -1. I want you to pause right now and try this out yourself. You require the center, you have the point, use the methodology that we have used just before this question, okay? Now let me show you the working. So we have the general equation x squared plus y squared plus 2gx plus 2fy plus c equals to 0. That's the general equation of a circle, right? We know that the center h comma k is minus g comma minus f, okay? So clearly the center for us will be, since you have minus 6x here, so negative of half of this. So that's 3 and 1 coefficient of y, negative half of that. Okay, so 1. So 3 comma 1 is the center. Do not forget this. Okay, this is the simple way of remembering it. Clearly, that means my circle would look like, or the equation of the circle will look like x minus 3 square plus y minus 1 square equal to r square a square, whatever is your radius, square of that. Okay. Radius also we know what it would be. Radius is square root of h square plus k square minus the constant term. So what you can do is, you can easily figure out r square. R square turns out to be 8. How? Because 3 square gives you 9, 1 square gives you 1, minus 2. The constant is 2, as you can see here. So minus 2, that will give you 8. So r square is 8, mind you. R square is 8. This is the equation of the circle that we have into consideration. Okay. Now that you have the center, M1, let's take that as slope of the perpendicular to the tangent at 1 minus 1. So M1 will be change in y upon change in x, just the way we figured it out. You have 2 points. Your center is 3 comma 1, and your other point where you have the tangent point of tangency is 1 comma minus 1. So change in y is 1 minus 3 upon change in x is minus 1 minus 1. So this gives you minus 2 upon minus 2. That gives you 1. So m1 is 1. If the slope of the perpendicular to the tangent is 1, by the rule of orthogonality, I know that the slope of the tangent will be equal to minus 1 upon m1. That is, it's going to be minus 1. So slope of the tangent is minus 1. Now the tangent y is, the equation of the tangent is y equals to mx plus c, and 1 comma minus 1 lies on it. Since 1 comma minus 1 lies on it, I can find out c. I have m already. So c is turning out to be 0. And how? See, your y is minus 1 equals to m is minus 1 into 1 for x plus c. Minus 1 cancels out. You get c equals to 0. So if c is equal to 0, that means y equals to mx plus c will be y equals to minus x plus 0, which means the equation of the tangent is actually x plus y equals to 0. Okay? That's the equation of the tangent. The next thing that I want to discuss with you in geometry is parabola. Now, what is parabola? Parabola is actually locus of a point which moves in a plane such that its distance from a fixed point, which is called the focus, is always equal to its distance from a fixed straight line, which is called the directrix. So the scenario looks something of this sort. Suppose this is your S and this is the point P, which has the coordinates x comma y. And this point A is actually the origin. Now this line that you see here parallel to the y-axis, this is your directrix in this case. So MZ is actually the directrix. S is the focus that you have. S is the focus. A is 0, 0. And the length AS will be same as the length ZA. Okay. Now let's call that length A. AS is equal to AZ. And let's call it A, and A is positive. So what do we know by distance formulas? What we can find out, we have point P with us, we have point S with us. We can find out the length of PS. So PS or SP, that's going to be equal to, by the distance formula, it's going to be equal to square root of x minus a whole square plus y minus 0 whole square. That is, it's going to be square root of x minus a whole square plus y square. Let's keep it aside. Now, PM is equal to Zn, as you can see here. PM, this length is equal to this length that you can see here, right? Now, PM is equal to Zn, and Zn is actually equal to AZ plus AN, as you can see here. Zn is, let me change the color, this much amount and then AN. Okay. Now this is A. You know that this is A, right? And AN is basically this much amount, this much length, and this length is nothing but x, because this point here that you can see here is x comma y, which means this much length is y and this much length is x, since this is the y-axis. Okay, so that means Zn or MP, they're both equal, they're equal to A plus x. And what now you can see is that by the definition of a parabola, for a parabola, your SP should be equal to PM. That's what it basically means, locus. So your SP should be equal to PM. And that is why you get your equation as SP square is equal to PM square. So getting rid of the square roots, you will get x minus a square plus y square equals to a plus x whole square. And when you will solve it, When you will solve it, things cancel out. As you can see, you have x minus a square here. Here you have a plus x whole square. So a square, x squares will cancel off and you will be left with just 4ax. That's how you get the equation of the parabola. So this is the equation of the parabola whose vertex is 0, 0. As you can see, the vertex is 0, 0. Now I am interested in again figuring out some relation of the parabola with the tangent at a particular point. So equation of tangent of a parabola, say y square equals to 4ax. Again, the concept remains the same. Equation of a tangent, that's a straight line, so it will be y equals to mx plus c. Okay. Now, few points. Y equals to mx plus c is a tangent to y square equals to 4ax if c is a by m. So a is here and m is here. So if c is a by m, then y is equal to mx is a tangent to y square equals to 4ax. Let me just find out few things for you. We have y square equals to 4ax. So if I differentiate on both the sides, I'm going to get 2y dy by dx is equal to 4a, right? That's the first thing that I will get. With this, I can actually figure out dy by dx. And dy by dx is nothing but the slope m, right? So dy by dx is 2a upon y. Suppose the tangent is at the point x1, y1. So that means dy by dx will become 2a upon y1. Or in other words, m, your slope m of that equation will become 2a upon y1. Equation of a line passing through x1, y1 is y minus y1 equal to m times x minus x1. Okay, that's the equation of the line passing through some one point x1, y1. We know what m is. So that means equation of this line becomes y minus y1 is equal to 2a upon y1 into x minus x1. If you take y1 to the other side, take the LCM, that's what you will get. You will get y by 1 minus y1 square is equal to 2ax minus 2ax1. I can take 2a common also, of course. Now, what do I know? This point, since I have the tangent at this point, okay, your tangent is at this point. Whatever line you're talking about, x1, y1, it's actually lying on the parabola also. Because you have a tangent at this point, right? So it lies on the parabola as well. So it lies on the parabola, that means y1 square will be equal to 4ax1. So that is why you can convert y1 square to 4ax1. Once you've done that, then it's very easy. You can take all the x terms together. So that's what I've done. So combining this and this term, you will get 2ax plus 2ax1 on the right hand side. So y into y1 is equal to 2a into x plus x1. And that becomes your equation. That's the solution to the problem. This is the equation for the tangent. Let me take another kind of example now. Suppose this time y square is equal to 12x. What is the equation of the tangent drawn from minus 1, 2? I will repeat myself. Drawn from minus 1, 2. We are in this question not saying that the tangency is happening at minus 1, 2. No, we are talking about a point from where I'm drawing the tangent to this parabola. So both the things are different. The previous question was a general form, was a different thing. This is a different thing. Okay. So we have a point, particular point. This time we have a particular parabola. Let's work it out. Now, I would like to see this parabola in my general form, which is y square equals to 4ax. 12x, that means I can write it down as 4 into 3x. So a is basically 3. I could figure it out from here. A is 3. Once I know that, Let's again talk about dy by dx here. So 2y dy by dx is equal to 12. So which means dy by dx is 6 upon y. Dy by dx is 6 upon y. Okay, let's keep this aside. Now, equation of the tangent is y equals to mx plus c of like any line, like any other line. Now, the tangency is not happening at -1, 2. But what do I know? I know that I'm making a tangent from this point -1, 2. That means -1, 2 lies on the tangent. So since -1, 2 lies on this tangent, it will satisfy this equation, right? So which means that I'm going to get, after putting in x and y, I'm going to get 2 is equal to minus m plus c. All I've done is I've put x as -1 and y as 2. Now for tangency, I remember I just mentioned in the beginning, c has to be a upon m, which means in our case, it will be equal to 3 upon m. So c is equal to 3 upon m, and I have this relation. Combining the two, what do I get? I get that 2 is equal to minus m plus 3 upon m. Now taking LCM and solving. Let's take the LCM. You will get 2m is equal to minus m square plus 3. Let me create a quadratic. M square plus 2m minus 3 equals to 0. Taking everything to one side. I think I can factorize this. I can factorize this. You have minus 3 here. You have 2m here. So you can take 3 and minus 1. So the two factors that you will get is m plus 3 into m minus 1 equals to 0, which means m could be minus 3 or m could be 1. So m could be minus 3, m could be 1. Hence, the possible tangents are, you already have c, now you have two values for m. You can figure out the two tangents possible. Y is equal to minus 3x plus 3 upon minus 3. Don't forget, you have particular m. So I am taking m here as minus 3. When I take m as minus 3, this is what I get. And the equation looks like y is equal to minus 3x plus 1. Or you can take everything to one side also and say that it looks like 3x plus y plus 1 equals to 0. Or else, if you take m equals to 1, y will be equal to x plus 3 upon 1. Don't forget, we are putting in for c a upon m. So that means y is equal to x plus 3, or you can take everything to one side and say that it looks like x minus y plus 3 equals to 0. So this was a different case, okay? We did not have the point of tangency, but we instead had that the tangent is coming from a particular point. That's also another kind of question that could be asked. Next quick brush up that I want to do with you guys today is the basic trigonometry. Now, what is trigonometry? Trigonometry is basically measurements associated to a triangle. That's why, you create a triangle, you have base, perpendicular, hypotenuse, and then you have all these thetas, sine theta, cosine theta, and so on and so forth, and results associated to them. So I'm just going to brush up few of the results with you guys, the basic ones, which you must know for when you're sitting for any of these entrances. So suppose you have a right angled triangle ABC, it's right angled at B. So this BC is your base, AB is the perpendicular, and AC is your hypotenuse. And the angle opposite to the 90 degree is, say, theta. In that scenario, few basic things that you should know. I just mentioned it in the beginning as well. Sine theta is perpendicular upon hypotenuse. Cos theta is base upon hypotenuse. Tan theta is perpendicular upon base. Cot theta is 1 upon tan theta. Cot theta is 1 upon tan theta, so automatically it will be base upon perpendicular. Secant theta, sec theta means secant theta. Secant theta is 1 upon cos theta, so it will automatically be hypotenuse upon base. Cosecant theta is 1 upon sine theta, so it will be hypotenuse upon perpendicular. So these are the basic things that you should know, the ratios. Then what else you should know? You should know the basic values. When theta is 0, 0 degree, 30 degree, 45, 60, 90, 180, 270, 360. That is till 2 pi. You should know what the value of sine theta would be, cos theta would be, tan theta would be. Automatically, you can find out for cosec, sec, and cot. So sine theta would be, it starts with at 0, it's 0, then 1 upon 2, then 1 upon root 2, root 3 upon 2. At 90, it is 1. And cos theta at 0 is 1, and at 90, it is 0. Sine 180 is 0, and cos 180 is minus 1. Sine 270, that is adding 90 to 180, you will get minus 1, is a negative quadrant. And then 360 again, you will get 0. For cos, it starts with minus 1, then you have root 3 by 2. It goes opposite basically. So root 3 by 2, 1 upon root 2. So cos theta and sine theta are equal at 45 degree. That's another important thing. And because of which tan theta, since tan theta is actually just the ratio of sine theta and cos theta, you will get 1. Now, cos theta is half at 60, then at 90 it is 0, as I said, at 180 it is minus 1, at 270 it is 0, then 360 it is 1. Tan theta is 0 at 0 because sine theta is 0. And at 30, it is 1 upon root 3. 45, it is 1. 60, it is root 3. At 90, it's not defined because the denominator becomes 0. Sine theta upon cos theta becomes 0. At 180, it is 0. At 270, it's not defined. At 360, it is 0, and so on and so forth. Cosec theta, since cosec is 1 upon sine theta, it is not defined at 0. Then you get 2, root 2. As you can see, these are just the reciprocals. So it's nothing but 1 upon sine theta. So just keep this in your head. Please keep this in your head. Okay. Now, this will be 1 upon root 3. The formulas that you must know. The formulas that you must know, sine square theta, the identities. Sine square theta plus cos square theta, no matter what theta is equal to 1. Tan square theta plus 1 is equal to secant square theta, or secant square theta minus tan square theta is equal to 1. Cot square theta plus 1 is equal to, just in the similar manner, cosec square theta. Okay. 3 identities and some more actually. Also, the ratio identity. So suppose you have a triangle like this. Suppose you have a triangle like this. So you have ABC triangle. If you have ABC triangle, and we will take the triangle sides as opposite to the angle. So if B is here, the right opposite, the length we will take lowercase b. If C, the angle is here, then right opposite you will take lowercase c. A is there, so I'm taking lowercase a here. So the sine ratio formula is A upon sine A is equal to B upon sine B is equal to C upon sine C. This will always hold true in any triangle. Then also what you should know is sine of minus theta, cos of minus theta. What happens to that? Sine of minus theta is minus sine theta, remember. Cos of minus theta is cos theta itself. Tan of minus theta is minus tan theta. Cosec of minus theta works like sine, so minus cosec theta. Secant of minus theta is secant theta, works like cos. Cot of minus theta works like tan. It's going to be minus cot theta. Apart from that, you should know sine A plus B. If you add two angles, sine A plus B is sine A cos B plus cos A sine B. Sine A minus B will be sine A cos B minus cos A sine B. Cos A plus B will be cos A cos B minus sin A sin B, and cos of A minus B will be cos A cos B plus sin A sin B. How can you use it? It's very simple. In case you have to say find out cos of 105 degree. So it's easy to break it in terms that you are aware of. You are aware of 60 and 45 for cos. So you can break it as cos of 60 plus 45, and now you can use the formula. Apart from other cases where you do use these identities whenever required. So this you can break and find the value cos 60 into cos 45 minus sin 60 into sin 45. You know the values of cos 60, cos 45, sin 60, sin 45. Just put the values in and you can find out cos of 105 degrees. It will turn out to be 1 upon 4 into square root of 2 minus square root of 6. What is important for you, and I'm giving you this as a homework. I'm sure you must be working at your end. And as I said yesterday, please do at least couple of questions around these concepts, because these are the basic concepts around which you could be asked questions. You should find out, using these identities, try to find out sine 2 theta, cos 2 theta, sine theta by 2, cos theta by 2. Please try to find out. These are also important identities. Apart from that, tan. Let's not forget about tan. So tan A plus B is tan A plus tan B upon 1 minus tan A tan B. And tan A minus B is tan A minus tan B upon 1 plus tan A tan B. So always remember these formulas. Also important for you to remember, cos 90 minus theta gives you sin theta. Sin 90 minus theta gives you cos theta. Tan 90 minus theta gives you cot theta. Okay. This is what I wanted to discuss in today's lecture. One more basic lecture I will take up, before your entrance, because I would like to discuss some more concepts which could be asked in your exams. All the best, all the times. Thank you. Hi guys, welcome to the next lecture. Today I have the plan to work with you guys on the concept of sequences and series. What is a sequence? Let's understand that first. A sequence is pattern. The word sequence, comes from pattern. So it is defined as an ordered collection of things. These things generally are numbers. So we can also say that a sequence is a set of numbers arranged one after another. Pattern and order is very important out here. In fact, sometimes we also refer sequences as progression. In progression or sequences, we generally put the terms like A1, A2, A3, so on and so forth. These are the terms, or you can say that these are elements of any sequence. This subscript that you see here, 1, 2, 3, 4, these are all natural numbers, and they indicate the position that the element is taking. That is why I kept on saying that order is very important. Position is very important. The word sequence actually stands for that. If when we are writing TN or AN or any other letter you can take, generally, TN for term N. So this, as I said, term N. So TN denotes the nth term of the sequence. So T5 would be the 5th term. T6 would be the 6th term. No matter what the term is, this is just denoting that what we're talking about is the 5th term. What we're talking about is the 6th term. Then what the term is, that's another thing altogether. For example, 3, 5, 7, 9, so on and so forth could be a sequence. If I say 7 I can say is the 3rd term. So I'm going to I can call it A3. Similarly, 9 denotes the 4th term. So I can call it A4, and so on and so forth. When you write down ... that means the sequence is going infinitely. So you have infinite terms here. Okay. So it makes me come to the next thing. which makes me come to the next thing, and that is sequences could be finite or infinite. Now, what is a finite sequence? Finite sequence is a sequence which consists of finite terms. An infinite sequence is a sequence which consists of infinite terms. For example, if I say the sequence is of natural numbers, 1, 2, 3, 4, 5, so on and so forth. This is, the set of natural numbers, everything written in a particular order. So I'm writing it ... because this is an infinite sequence. When I'm writing it ... If I write the numbers from 1 to till say 10, that means I'm just taking 10 natural numbers in this set, or this sequence is finite because you have finite terms here. Let's work on a problem now. Find out the first three terms of the sequence Tn, which is equal to minus 1 by n to the power n. How would you get the terms? You will get the terms by substituting. So you got to substitute n. Substitute the value of n. When I say first term, that will be T1. T1 will be minus 1 upon 1. Wherever you have n, just put 1. So you will have minus 1. T2 is equal to minus 1 upon 2 to the power 2. So that's going to give you minus half square, which will be positive 1 by 4. The third term will be T3. N is 3. So that's going to be minus 1 upon 3 to the power 3. Since it's cube, negative will give you negative. So minus 1 upon 27. And that's how you can find out every next term. That's what is sequence all about. It is always depicted in terms of an, where n is a natural number. It could be up till a finite point or moving to infinity. Moving on, let's talk about arithmetic progression. So this is a very special type of progression or sequence. It's a sequence where in which successive terms, they maintain a constant difference. So what does this mean? Let's figure that out. What this essentially means is that you have a common difference in every two terms that you take. Consider A, the first term is A. The second term, if I say, is A plus D. So what just happened? We have added D to A. And we got our second term, which basically means that this is my term 1, this is my term 2. And when I will look into the difference of term 2 minus term 1, that's going to be D. If I take the third term as A plus 2D, this is my third term. And now if I will look at the difference between T3 and T2, term 3 and term 2, it's going to be D again. If I will take A plus 3D and see the difference between the fourth term. This is your fourth term and third term. Again, you have a constant difference, which is D. So you have a constant difference, which is called common difference. So arithmetic progression is all about this. You have a common difference in every two successive terms that you will take. And there are a lot of consequences when this kind of a thing happens. So we can find out the general term. General term, if you are looking at the nth term, if you want to figure out what is the nth term. And since you know that it's an AP, so you know that you're moving A, then A plus D, then so on and so forth. Or in other words, A is your first term. So if A is your first term, A is the first term, then clearly what I've done here is, if I want Tn, that is the nth term, what we have to do is, in A, I have to add n minus 1 times D. See what we did here? The second term was A plus D. The third term was A plus 2D. And we saw you get a common difference, right? So what is the general term for an AP? Tn, that is the nth term, will look like A plus n minus 1 times D, where A is the first term and D is the common difference. The moment you use the term common difference, it means every two terms that you will take, the successive terms, the difference will be of D. It's a constant D. Okay. Few points that you must note. Number one, n is a natural number. Number two, common difference can be 0, it can be greater than 0, it can be less than 0. Anything can happen. When the common difference is greater than 0, clearly every next term is increasing, right? So it's an increasing arithmetic progression, or it's an increasing sequence. And in fact, the sequence will tend towards plus infinity because it's getting bigger and bigger and bigger and bigger. So it will tend to plus infinity. If d is less than 0, then it's a decreasing arithmetic progression and the sequence will tend to minus infinity. If difference is 0, then that means you are adding 0 to a every time, right? So if you're adding 0 to a every time, that means it's a constant sequence. Nothing is ever changing. It's a constant sequence. It is just the sequence which consists of A. Another important point I want to make here. Suppose T1, T2, so on and so forth till Tm. This is an arithmetic progression that you have. In case you want to figure out the nth term from behind, your end term is Tm. You have m terms, okay? And you want nth term from behind. How do I get that? That would mean that I have to move backwards. Actually, n minus 1 times I have to move backward. And then only I will be able to reach my nth term. And nth term will basically be the m minus n minus 1 term, because you're coming n minus 1 times back. Then only you can reach the nth term from behind, okay? So please remember that the nth term from the end is m minus n plus 1. That basically means n minus 1 term from the beginning, where m is the total number of terms, and it is given by, as I've written here, it is given by Tm minus, Tm is your last term minus n minus 1 times t again. See, because the common difference is always the same, that is why. Let's work on a question here. If fifth term of an AP is 17 and its seventh term is 15, then find the 22nd term. Let's do it. So we are given that T5 is equal to 17, which basically means that A plus 4 times D is equal to 17, and seventh term is 15. That means A plus 6D is equal to 15. If you will solve for this, what will you get? You will get A cancels. If I subtract, I'll get minus 2D is equal to 2, which implies D is equal to minus. Now you have D. Let's calculate the 22nd term by, first I need A. So A will be equal to 17 minus 4 times D. So that's going to be 17 minus 4 into minus 1. That means plus 4, that is 21. So your 22nd term, T22, will be A plus 21D, n minus 1. So n is 22, so 21D. A is 21. D is minus 1. So 21 into minus 1, that means you're talking about 21 minus 21, that's 0. So the 22nd term indeed is 0. One important point in AP, you must always remember that a sequence obtained by multiplication or division of corresponding terms of two APs may not be in AP. For example, if we take the sequence 2, 4, 6, 8, so on and so forth, and we take 1, 2, 3, 4, 5, so on and so forth, then if you will see the product, it's going to be 2, then 8, then 18, then 32. And you would notice that there is no set pattern in this, okay? So it need not be in AP. Next, let's quickly revise what is a series and how to work it out. A series essentially comes out of a sequence only when you add up all the terms. So if we have a sequence, say T1, T2, so on and so forth, T1, T2, T3, so on and so forth, the series we can get out of it is T1 plus T2 plus T3 plus so on and so forth till say Tn. That means we've added n terms. When we have added n terms, we can call it say Sn. So if you denote Sn, that means what you have done is you have added the first n terms of the given sequence. So Sn denotes that. Again, subscript n, very important. It is telling you how many terms have been added, what terms have been added. For example, if I have, let me talk about notations now. So many a times we use the summation notation, okay, the sigma notation. Now, what do you mean by the sigma notation? Sigma notation, when n goes from 1 to say 9, and we are adding just n. So this would mean when you open it up, sigma notation is basically standing for add. So 1 plus the next term, you add 2, plus the next term, you add 3, so on and so forth, till n equal to 9 you have to add. So till 9 you are adding, okay? So that's what is your S9 you will say. This is what is your S9. Your n is 9 here. Similarly, you can have say some other something else that you are adding up. Say you are adding r to the power a, where r goes from 1 to n. Summation is basically telling you just start giving value to r. If you start giving value to r, that means you're adding 1 to the power a, plus then you're adding 2 to the power a, plus you're adding 3 to the power a, and you are going till n to the power a. This would be called Sn because you're adding n terms and moving till n. Okay, so this is what you will say. You will call it n. Now, what are the properties of sigma? For sigma, there are some properties you must remember. Please write down. So you're adding a k times, a plus so on and so forth till a. How many times? K times. So this is nothing but k times a. It's simple sum. Then the next property that you must remember is that summation ai, where I goes from 1 to k, is equal to summation. Second property that you must remember is summation a times I, where I goes from 1 to say k. Now this is different. In this, a is a constant, it can come out, and it's summation I goes from 1 to k. So what's happening? You have a, and then you are adding 1 plus 2 plus 3 till you're adding it till k. A is a constant, okay? Here, A is a constant. Then the third property is adding or subtracting the sums. So summation of AI plus or minus BI, I goes from say 1 to n. This you can break, and this could be written as AI, summation AI, I goes from 1 to n, plus summation bi, I goes from 1 to n again. So you can break that, plus or minus, okay? But always remember, this does not hold true for products in sum. Now, another one is about the double summations. Double summations like ai, aj. So I goes from say I naught to in, and j goes from say j naught to jn. This could be interchanged as well. This could be summation, double summations, just like double integrals could be interchanged as well. This is not that basic, but yeah, I just wanted to add it as a property of sum you should know. That is why. So I can write I goes from I naught to in, and I can write j goes from j naught to jn here. Okay. Now let me take you back to the arithmetic progression, and let's talk about series of AP. series of AP. So how you can obtain series of AP? You know the terms in AP, A plus D, so on and so forth. So Sn, that is the sum of first n elements of an AP, will be A plus D plus A plus 2D plus so on and so forth. We're going till Tn. So that would be A plus n minus 1 times D, right? Now I want to actually derive a formula to it. For that, what I'm going to do is I will rewrite this sum, but in the reverse order now. See, 1 plus 2 plus 3 plus 4 is same as 4 plus 3 plus 2 plus 1, right? So I'm going to write A plus n minus 1D. Sn will still remain the same, right? Plus, then the next term will be A plus n minus 2D. So on and so forth. Then it will go up till A plus 2D, A plus D, A plus A, just A. Just A, right? So if you add the two, you will get twice of Sn here because you're adding. What will you fetch on this side? You will fetch 2n, you will fetch 2a plus n minus 1d. If you will add this and this, you will get 2a plus again n minus 1 times d plus so on and so forth. For every term, that's what you will get. You will get 2a plus n minus 1 times d. So what are you actually fetching? How many times are you fetching this? There are n terms, right? So you're fetching n number of times. You're getting 2a plus n minus 1 times d. So that means Sn actually is n upon 2 into 2a plus n minus 1 times d. What is Sn? Sn is basically the series of AP. That is when you start adding an arithmetic progression, arithmetic sequence. Then you get this formula to the sum. Sum of n elements would be this. Geometric progression is basically a sequence of non-zero numbers. If the ratio of successive terms is constant, which basically means that you'll have a scenario where, say your first term is A, and then the next term is AR, then the next term is AR square. So do you see what's happening? If you will see AR upon A, you're going to get R, which is a constant thing. When you will take AR square upon AR, you will again get R. So that's the common ratio that you have. AR cubed, so on and so forth, depending on whether it's a finite case or an infinite one. If it is, you're looking at n terms, then your nth term will be AR to the power n minus 1. Okay, so that's what is a geometric progression. In this general term, we will be looking at the general term Tn as AR to the power n minus 1. Index depends on what is your starting term. If your starting term, which generally, I'm giving you a general scenario where the starting term is A, then AR, then AR square, and so on and so forth, then your nth term will be AR to the power n minus 1 because you have n terms in total starting from A. Okay. Now, suppose you have a question here that if your 5th, 8th, 11th term of GP are P, Q, and S respectively, then find Q square. So let's work at it. So your 5th term, T5, is equal to P. That implies AR to the power 4 is P. T8 is Q. That implies AR to the power 7 is Q. T11 is R. That implies AR to the power 10 is R. So we have P, Q, R. That could be written like this. Okay. Now, I need square of Q. So Q square is equal to AR7 to the power 7 square, or in other words, it is a square, and r to the power 14. Now, r to the power 14, let's see what it is. It can be written as a square r to the power 4 into r to the power 10, because if the base is same, you can add the powers. So 14 could be broken like this. So that means I have nothing but ar to the power 4 into ar to the power 10. Ar to the power 4 is p and ar to the power 10 is r. That means in this scenario, q square is actually p into r. That's what I've taken, r, right? We've understood the term series, right? So geometric series would be when we are adding the terms of a geometric progression or geometric sequence. So Sn, that means will be a plus ar plus ar square plus till nth term. So ar n minus 1 in the power. That's what will be your general term Sn here. Now we would like to, try to figure out what would be the formula to it. If I multiply r on both the sides, so r Sn will be equal to ar plus ar square plus so on and so forth till ar n. Okay. Now what you can do is you can subtract the two, and I'm going to get Sn common into 1 minus r. And here, if you subtract the like terms, what will happen? Just a is left from above, because you can, let me just change the color. So you will cancel this out. This will cancel, everything will cancel. A would be left plus, in the end, ARN would be left, right? So Sn, that means is, A could be taken common, 1 plus Rn, 1 minus, sorry, 1 minus Rn, 1 minus Rn, whole thing upon 1 minus r that comes from that side. Now, this can only happen when r is not equal to 1 for a simple reason. In the denominator, you cannot have 0. Okay, so existence has to be there. So this will happen when r is not equal to 1. This is what your sum of n terms is given like, okay? This is what you get as a sum of any particular series. Sum of n terms will be given like this. And then, you can have a case where n goes to infinity. That is, you're adding infinitely. As n goes to infinity, what's going to happen is that r to the power n goes off in case r is, mod r is less than 1, strictly less than 1. Then what will happen is, Rn would actually become 0, because then it's just a fraction between minus 1 and 1, and you keep on multiplying by itself again and again. It will become minuscule, just almost 0. So as n tends to infinity, in this scenario, what will happen? You will just be left with a upon 1 minus r. So Sn will just be a upon 1 minus r when mod r is less than 1. When r is anything else, then you will get infinity. So your sum will keep on, diverging. Let's also work with harmonic progression today. So what is a harmonic progression? A sequence is in harmonic progression in case the reciprocals are in arithmetic progression. So for example, if say A1, A2, A3, they are in harmonic progression, that basically means they are in HP, 1 upon A1, 1 upon A2, and 1 upon A3, they are in AP. Then only this is happening, okay? So herein, what you would realize is that a standard harmonic progression is of the form 1 upon A, 1 upon A plus D, 1 upon A plus 2D, so on and so forth till 1 upon A plus n minus 1D, because the reciprocals definitely are in arithmetic progression. We've already done that, right? So this is what you need to know about harmonic progression. And apart from that, certain things that you should note down. Number one, 0 cannot be a term of a harmonic progression. 0 will not be a term of a harmonic progression because infinity is 1 upon 0 would mean infinity. That cannot be an arithmetic progression, It's not a finite number that you would see. So that is why 0 cannot be a part of a harmonic progression. Number two, there is no general formula for finding sum. No general formula. You can always use arithmetic progression to figure it out. No general formula for sum. Number three, if ABC are in harmonic progression, that implies 1 upon A, 1 upon B, 1 upon C is in arithmetic progression. Therefore, 2 upon B will be equal to 1 upon A plus 1 upon C, which essentially means that B will be equal to 2AC upon A plus C. What have I done? We know that the common difference, so 1 upon B minus 1 upon A is same as 1 upon C minus 1 upon B, and therefore you will get this term. Okay? And therefore you get that B has to be twice of AC upon A plus C. This is a very common question in entrances. This has been asked as basic and advanced in many entrances for that matter. And many entrances in which you are asked mathematics. It's not just economics that I'm talking about, but entrances wherever you are asked basic maths, you can be asked this question. This is a very, very common question, something that you must probably remember. Let's work on a question. So suppose the third term, sixth term, and last term of an HP is 1 upon 3, 1 upon 5, and 3 upon 203. You have to find n. How many terms are actually there? Okay, so what do you know? That an, I'm going to call it an or tn, whatever you want to call it, you can call that. So that's what is this. So, well, what we will use here is that I know that 1 upon the term, 1 upon the term in HP is in AP. So, Tn for an AP, Tn, the nth term is A plus n minus 1d. Now, this means that if we consider AP associated to this harmonic progression, then my third term is 3. Third term of AP is 3. Sixth term of AP is 5. And the nth term of AP is 203 upon 3. Okay. So what can we say? We can say that A plus n minus 1d is equal to 203 upon 3. And we also know that we can also say that A plus 2d is equal to 3 and A plus 4d is equal to 5. And therefore, by solving, A plus 5d is 5. A plus 5d is 5. So first, let's solve these two equations. Very simple. So if you will subtract, you will get AA cancels off. You get minus 3d is equal to 3 minus 5 will give you minus 2. So D is equals to 2 by 3. D is 2 by 3. Clearly, A is 3 minus 4 by 3. That means A is 5 by 3. So you have A, you have D. So which essentially will give you from here that 5 by 3 plus n minus 1 times 2 by 3 is equal to 203 by 3. And hence you know that 5 plus n minus 1 times 2 or 2 times n minus 1 is 203. And that would imply, so you get your answer here, that would imply you have 5 minus 2 plus 2n is equal to 203. Hence, 2n is equal to 203 minus 3, that is 200. So n is equal to 100. So there are 100 terms in this harmonic progression that we just worked with. Okay. So this is what I wanted to discuss in this video. I wanted to discuss your progressions, AP, GP, and HP. It's a basic math
Let's work on some questions from straight lines. So the first question that I'm picking up is about parallel lines. The lines p into p squared plus 1 times x minus y plus q is equal to 0 and p squared plus 1 whole square into x plus p squared plus 1 times y plus 2q equals to 0. They are perpendicular to a common line for what value of p? That's what we have to figure out. So is it exactly 2 values of p, more than 2 values of p, no value of p, or exactly 1 value of p? So let's just figure this out. So guys, you're given 2 lines which are perpendicular to the same line. If these 2 lines are perpendicular to the same line, what does it, pictorially mean to you? Well, I guess it's going to be something of this sort. So you have a line, and these are 2 parallel lines. If they are 2 parallel lines, so they're like straight 90-degree lines, right? So which means that two perpendicular lines. So these two lines, the equations that have been provided to you, these 2 lines are perpendicular to a common line. So which means that they will be parallel to each other, because perpendicular means 90 degrees. So both are 90 degrees. So that means they're parallel to each other. And in case 2 lines are parallel to each other, that means the slope is the same, right? The slope is the same. So slope of line 1 is same as slope of line 2. Now, the slope of line 1 is minus p into p squared plus 1 whole thing upon minus 1. You can check for yourself. So it is minus the coefficient of this upon the coefficient of this, right? So minus the coefficient of x upon the coefficient of y minus a by b. So similarly here, minus p squared plus 1 whole square upon p squared plus 1. You just have to solve for this equation. That is it. So, which essentially means that, let's cancel things here. So, of course, p squared plus 1 p squared plus 1 goes off from here. P squared plus 1, p squared plus 1 goes off from here. So, what do we have here? So, minus goes off from here. So, what I get is that p is actually minus 1. It's a unique value of p. So there's just exactly one value of p, which is giving us, which is solving this situation. So D should be the correct answer. Number 4 should be the correct answer. That exactly one value of p is satisfying this situation. So what have we done here? What we have done here is that you were given 2 lines, and the 2 lines are perpendicular to a common line. If they're perpendicular to a common line, that means they are falling off like this, 90-degree slope on this common line. So these two lines are, that means, definitely parallel to each other. If they're parallel to each other, the slope is same. Of course, it's 90-degree, 90-degree if we talk about this line. So if their slope is same, we know the slope formula. We will use the slope formula and equate it, and that will give you a value of P. Next question. A straight line through a fixed point 2, 3 intersects the coordinate axis at distinct points P and Q. If O is the origin and the rectangle OPRQ is completed, then locus of R is, okay. You have 4 options in terms of, the line. 2x plus 3y equals to xy is the locus. 3x plus 2y equals to xy is the locus. Or 3x plus 2y equals to 6 times xy is the locus. Or 3x plus 2y equals to 6 is the locus. What is locus? The question arises, what is locus? Locus is essentially, it's the set of points. It could be, a line segment. It could be a curve, a surface. It's a set of points whose location satisfies some conditions. It could be one condition or more than one condition. So we are interested in the locus of the point R. Suppose the point R is H, K. So let's talk about the situation that we have. So we have a line PQ which passes through 2, 3. So this is 2, 3 somewhere. This line passes through. It's PQ. It passes through 2, 3. And we are completing the rectangle. We are completing the rectangle OPRQ. So please look at the directions OPRQ. Okay. So this is how it will go. So P is here. Then R is here. Then Q is here. This is the lines. This is the line passing through 2, 3. When it cuts Y here, Y axis here, this you get Q. And when it cuts the X axis here, you get P. Now, if the point R is H, K, it's a rectangle. So the relation is such that this point, because this length has to be equal to this length, and this length has to be equal to this length. So the point is such that P will be H, 0. Of course, it's x-axis, so Y is 0. So H, because it has to be the same as what you have for R. And this point is 0, K. Now, what the situation is, we're interested in locus of R. Locus of R means that all the points that will satisfy the condition that R is also satisfying, right? So what are the conditions that we get from here? So first of all, what we can get is equation. Please try to understand when we say R, we're talking about H, K. What conditions H, K will satisfy? So we have equation of PQ. Clearly, equation of PQ is, it's going to be X upon H plus Y upon K equals to 1. Equation of PQ would be X upon H, Y upon K equal to 1. Now, what else is happening now? PQ passes through, this line PQ passes through. So, all the X, Y's which are passing through, when you have X here, Y here, that means you're talking about whatever value of X and Y will be there on this line. So it will satisfy this equation. Now PQ passes through 2, 3. PQ passes through 2, 3. That means x2, y3. So you get another condition, that is 2 upon h plus 3 upon k equals to 1, right? 2 upon h plus 3 upon k is equal to 1. So now what have you actually got? You've got a condition of h and k. H and k, which is h is the x-axis value, y and k is the y-axis value for r. H and k satisfy this equation, right? So in other terms, when I want a generalized, I want in terms of generalized xy, the equation, the locus basically means satisfying this condition. Point R, that is h comma k, satisfying a condition. This is the condition it satisfies. So in a general form, you can write 2 upon x plus 3 upon y equal to 1 is the locus of R. Is the locus of R. Or in other words, if you take the LCM, you will get 3x plus 2y is equal to xy. So what do you have? Do we have this in the options? 3x, 2y is equal to xy. It's option 2. So this is how you find out locus. Locus is basically the set of points satisfying a certain condition. This time the conditions were associated to the point R. So R point I've taken as h comma k. So what is the property that h comma k is satisfying? That is what we have found out in a generalized form. When it is in generalized form, you will give an answer in x and y.